Let me ask you something simple. Something you can answer while lying there in the dark, not moving, barely awake. What are you? I don't mean it in the grand way. I'm not asking about your soul or your hopes or the story you tell yourself about who you are. I mean it in the plainest, most stubborn, most physical way I can manage. Right now, as you rest there, as the air goes gently in and out of you, what is the actual stuff of you? What would I find if I could take you apart and lay every piece on a very large table and count? Here is the answer, and it is a real number, not a poem. You are, near enough, 7 octillion atoms. If you want to see that written in your mind, it is a 7 with 27 zeros trailing off behind it. 7 times 10 to the 27th. That is the whole census of you. Every thought you have ever had, every ache in your knee, every freckle, every memory of your grandmother's kitchen, all of it is being carried out right this second by 7 octillion little specks of matter and nothing else besides. Now I want to be careful here, because I'm going to say something that sounds like philosophy, but is really just physics, and I want you to feel the difference. I once said, and I still believe it down to the ground, that there is nothing that living things do that cannot be understood from the point of view that they are made of atoms acting according to the laws of physics. Nothing. Not the beating of your heart, not the firing of the nerve that lets you feel the blanket against your skin, not love, not grief, not the peculiar business of you lying there wondering about any of this. All of it is atoms, and only atoms, doing what atoms do. And what do atoms do? Here I'll give you the one sentence I've always thought was the most valuable single sentence in all of science. The one I'd want to survive if every other bit of knowledge were lost in some catastrophe. All things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. That's it. That's the whole secret. Little particles, always jiggling, pulling together when they're near, pushing apart when you shove them too close. Everything else, all of chemistry, all of biology, all of you, is just an enormous and elaborate consequence of that one sentence played out over 7 octillion pieces. So hold that picture. You, resting in the dark, are a vast swarm of jiggling specks, each one pulling and pushing on its neighbors, and somehow out of all that blind mechanical fidgeting comes a warm breathing thing that can ask what it is. That alone should be enough to keep anyone up at night, except we're trying to do the opposite here, so let it settle instead. Let it be a calm fact. You are a swarm, and the swarm is humming along, and it feels from the inside like a single solid person. But here is where it stops being cozy and starts being strange, and I want to walk you into the strangeness slowly, one step at a time, because there's no rush tonight. We have all the time in the world. That swarm of 7 octillion atoms. You feel like it's yours. You feel like it's you, the same you that was here last year and the year before. But it isn't the same swarm. Not even close. More than 90% of the atoms that are in your body tonight were not in your body 1 year ago. Let me say that again slowly, because when I first really understood it, it took a while to sink all the way in. More than 90 out of every 100 atoms in you right now are recent arrivals. A year ago, they were somewhere else entirely. In the air, in a field, in the ocean, in a potato, in another person. And a year from now, most of the atoms that are you tonight will have left, scattered back out into the world and been replaced by yet another crowd of strangers. You are not a thing. You are more like a flame, or a fountain, or a standing wave in a river where the water is always rushing through but the shape stays put. The water in a wave is never the same water. Stand by a stream and look at the little standing ripple that forms behind a rock. It sits there, holding its shape hour after hour, and yet not one drop stays in it for more than an instant. The ripple is real. You can point to it, photograph it, describe it. But it is not made of any particular water. It is a pattern that the water is passing through. That, and I mean this quite literally, is what you are. The atoms come into you, and they take up their positions, and they do their work, and then they leave, and new ones come and take up the same positions and do the same work. What persists is not the material. What persists is the arrangement, the pattern, the dance. I called it a dance once, and I've never found a better word for it. The atoms come into my brain, dance a dance, and then go out. There are always new atoms, but always doing the same dance, remembering what the dance was yesterday. Isn't that a curious thing to sit with, there in the dark? The atoms that are, at this moment, holding the memory of your childhood home, the specific pattern of them that lets you walk through those rooms in your mind, those very atoms will be gone within weeks or months, drifting through some cloud or some blade of grass, utterly ignorant of the home they once helped you remember. And the memory will still be there, because the new atoms will have slid into the same dance and picked up the step exactly where the old ones left off. I used to put it to my students in a way that made them laugh and then made them go quiet. The potatoes I ate last week, I'd say. The atoms from last week's potatoes. They are now busy inside my head, and they can remember what was going on in my mind a year ago, in a mind which has long since been entirely replaced. Think of it, the stuff of your dinner, promoted overnight into the machinery of your thinking, holding your oldest memories, and then dismissed again into the wide world, and none of it, not a single atom, the least bit aware of the strange duty it just performed. So we have this first surprise, and I want you to really have it before we go any further, because everything tonight is going to be built on it. You are not the atoms. You could never have been the atoms, because the atoms don't stay. You are the pattern the atoms are performing. Identity is not a substance. It is a choreography. It's a dance that the matter keeps learning, dancer after dancer, none of them the same, all of them doing the same steps. And once you truly see that, a very natural question arrives, the way a lit fuse arrives at the thing it was lit for. If you are only the pattern, and the atoms are only passing through, and they've been passing through your whole life anyway, flowing in and flowing out, 90% of them swapped fresh every single year. Then a question about death stops being frightening and starts being, of all things, a problem in arithmetic. Because what is death in this picture? It is not the atoms vanishing. Atoms don't vanish. As far as we can tell, they are very nearly eternal on any human scale of time. The carbon in you was forged in a dying star long before the Earth existed, and it will still be carbon long after you and I and everyone we've ever known is gone. Death does not touch the atoms at all. The atoms don't even notice. They go right on jiggling, pulling and pushing on their neighbors, doing the one thing they know how to do. What death does is much simpler and much stranger than an ending. All your life, the atoms have been flowing through you in both directions at once. In through your breath, in through your food and your water, out through your breath, out through your skin, out through everything your body lets go of. A river running two ways at the same time, in and out, and the balance of it holds the pattern steady. Death is nothing more than the moment that river stops running two ways and starts running one way only. The doors that let atoms in swing shut. The doors that let atoms out swing wide. And the great outflow begins. And that outflow is the story I want to tell you tonight. Not as a sad thing, not as a frightening thing, as one of the most extraordinary journeys in all of nature, followed atom by atom, element by element, with real numbers attached at every step. Where does the carbon go? Where does the nitrogen go? The phosphorus that is at this very moment firing the neurons that let you understand this sentence? Where does that end up? And how soon? And by what road? And when we've followed every one of those 7 octillion travelers out into the world, I'm going to show you something with the arithmetic that I promise you will not be able to put down. Something about how far those atoms travel, and how many other bodies they've already been part of, and how many of yours are right now inside everyone else. But we go slowly. We start where all of it starts. We start with the inventory. Before we can follow the atoms out, we have to know exactly what is in the warehouse. So let us count. 7 octillion. Let me say that number again slowly, because you cannot feel it and neither can I, and yet we are going to spend the next while getting acquainted with it as best we can. 7 times 10 to the 27th. That is a 7 followed by 27 zeros. If you tried to count them, one atom every second, never sleeping, never eating, never pausing, you would not finish before the sun burned out. You would not finish before the sun burned out 100 million times over. And all of that, every last one, is packed into the warm, quiet shape of you right now in the dark. So what are they? Not all the same, of course. If you took a census of your atoms the way a town takes a census of its people, going door to door counting heads, you would find that the most common citizen by far, the fellow you meet everywhere, is hydrogen. 62 out of every 100 atoms in your body is a single hydrogen atom. 62%. More than half of you, by simple head count, is the lightest, simplest, oldest atom there is. One proton, one electron, and almost nothing else. The first thing the universe ever made, still the majority shareholder in the enterprise of being you. Now that surprises people, and I understand why. You do not feel like you are mostly hydrogen. You feel solid. You feel like meat and bone and weight. And here is the little trick the arithmetic plays. Hydrogen is so light that even though it wins the head count in a landslide, it barely shows up on the scale. Counting atoms and weighing atoms give you two completely different pictures of the same body, and you have to hold both in your mind at once, because they will matter enormously when we start letting these atoms loose into the world. Let me give you the other picture. By weight, hydrogen slips from first place all the way down to third. By weight, the champion is oxygen. 65% of your mass is oxygen atoms, mostly because you are, more than anything else, water, and water is two little hydrogens clinging to one big heavy oxygen. Then comes carbon, at 18.5% of your weight, the atom that builds every strand and scaffold and membrane in you. The atom that life is truly written in. Then hydrogen, at 9.5%, light as ever. Then nitrogen at about 2.5%, the atom hiding inside every protein, every muscle fiber, every thought. And after that, a long tail of the rarer folk. Calcium locked in your bones. Phosphorus, which we will come back to because phosphorus has a secret. Sulfur, potassium, sodium, a pinch of iron, a whisper of everything else. Hold those two censuses side by side. By head count, you are 62% hydrogen, 24% oxygen, 12% carbon, and barely 1% nitrogen. By weight, you are 65% oxygen, 18.5% carbon, 9.5% hydrogen, 2.5% nitrogen. Same body, same you. Two different stories, depending only on whether you are counting souls or weighing them. Nature does not care which story you prefer. Nature keeps both sets of books, and both are exactly true. Now, why am I dwelling on this bookkeeping, when what I promised you was a journey? Because the road each atom takes out of you when the time comes is decided, entirely and in advance, by which atom it is and what molecule it was living in. The oxygen has one fate. The carbon has another. The nitrogen goes off on a long adventure through the soil that I cannot wait to tell you about. The phosphorus does something almost stubborn. To follow them out, we have to know not just how many there are, but how they are arranged, what rooms of the house they were living in. And the house, it turns out, has only a few kinds of rooms. Here is the whole floor plan. If you could take a living human body, weigh it wet just as it is, and sort every gram by what it belongs to, you would find that roughly 64% of you is plain water, nearly 2/3. You are, to a first approximation, a very cleverly organized puddle. Then about 20% is protein, the long folded chains that build your muscles, your enzymes, your skin, your hair, the machinery that does the work. Then about 10% is fat, the dense quiet fuel, the padding, the reserve. Then a mere 1% is carbohydrate, the quick sugar the body keeps on hand like small change in a pocket. And the last 5% is minerals, the hard stuff, mostly your skeleton, the calcium and the phosphorus set in crystal. Water, protein, fat, carbohydrate, mineral. That is the entire inventory of the warehouse. 64, 20, 10, 1, 5. Remember those 5 numbers, because every gas that will one day rise out of the ground where a body lies, every stain that will change the soil for years, every atom that will drift away on the wind to join another living thing, comes from one of exactly those 5 rooms. There is nothing else in there. There is no mystery ingredient. There is no secret vital fluid that the old philosophers imagined, no spark that lives apart from the matter. There is water, and protein, and fat, and a little sugar, and some mineral, all of it made of those same 7 octillion atoms, and all of it obeying without exception the plain laws of physics and chemistry. And I want to pause on that, because it is the whole foundation of everything I am going to tell you, and it is easy to say too quickly. There is nothing that living things do that cannot be understood from the point of view that they are made of atoms acting according to the laws of physics. Nothing. Not the beating of the heart, not the firing of a nerve, not the folding of a protein, not the moment you understood your first joke, not the moment, whenever it comes, that the whole arrangement finally stops. All of it, every bit, is atoms attracting each other when they are a little apart and pushing back when they are squeezed too close. That is the only rule. From that one rule, and enough time, and enough atoms, comes everything. Comes you. And, when the time is right, comes the unmaking of you, which is not a violation of the rule, but simply the rule continuing to run after the machinery that held the pattern together has let go. So do not think of the inventory as morbid. Think of it as the guest list for a very long party, at which every guest is going to leave by a different door, at a different hour, headed for a different destination, and we get to stand by the doors and watch each one go, and follow it if we can. The water leaves one way. The protein comes apart into its nitrogen and its carbon and its sulfur, and each of those has somewhere to be. The fat, which is mostly carbon and hydrogen, burns slowly and quietly into gas. The sugar goes almost before you notice. And the minerals, the hard, patient minerals of the bone, those are the last to leave, and some of them, under the right soil, do not leave for a very long time at all. But before any of them can leave, I have to show you something strange about the warehouse itself. Something that unsettles the whole idea of leaving and arriving. Because you might picture your atoms as long-time residents. You might imagine that the carbon in your hand has been your carbon since you were small, that these are your atoms, gathered once and held for a lifetime, and that death is the moment they are finally released. That picture is beautiful. It is also completely, wonderfully wrong. The atoms in you tonight are not the atoms that were in you a few years ago. They are not even mostly the same atoms that were in you last year. The warehouse is not a warehouse at all. It is a river. Things are pouring in one end and pouring out the other every single second that you are alive. And the shape we call you is not the water. The shape we call you is the standing wave. And once you truly understand that the leaving has been happening all along, that you have been dispersing into the world every day of your life and pulling the world back into yourself with every breath and every meal, then death stops looking like a door slamming shut. It starts looking like something much gentler and much stranger, and I think much more true. It starts looking like the moment the river stops flowing back in and only keeps flowing out. But to earn that idea, to feel it in your bones rather than just nod at it, I have to take you into a laboratory and I have to tell you about a rat, and a trace of something faintly glowing, and a brain that emptied itself and refilled itself in the time it takes a bruise to heal. So let me set the scene for you, quietly. There is a laboratory, and there are scientists who want to know something that sounds almost impossible to know. They want to follow a single kind of atom on its journey through a living creature. Now, an atom of phosphorus looks exactly like every other atom of phosphorus. You cannot paint one red. You cannot tie a little string to it. If it goes into a brain and mingles with the 10 billion others already there, how on earth would you ever pick it out again and say, ah, that one, that is the one I put in on Tuesday? Here is the trick, and it is a lovely one. Some atoms of phosphorus are slightly unstable. They are built just a little differently in the core, the nucleus, and every so often one of them will quietly rearrange itself and give off a faint whisper of radiation. It is a signal. It is a tiny voice saying, I am here. I am here. So if you feed a creature phosphorus that carries this faint voice, this radioactive phosphorus, you can then hold a detector nearby and listen. The louder the whisper, the more of your marked atoms are sitting in that spot. You have, in effect, put a lantern on a few travelers in an enormous invisible crowd, and now you can watch where the crowd carries them. And so they did this with a rat. They gave the rat phosphorus that glowed faintly to the instruments, and the phosphorus went where phosphorus goes. It went into the bones, and into the machinery of the cells, and up into the brain, into the cerebrum, the big wrinkled part where, if a rat has thoughts, the thoughts would live. And then they simply listened, day after day, to how loud the whisper stayed. Now think about what you would expect if the brain were a solid, settled thing. You would expect the phosphorus to arrive, take its place in the architecture, and stay put. The brain is not a muscle you are tearing and rebuilding at the gym. It feels, from the inside, like the most permanent thing you own. Your memories are in there. The face of someone you loved is in there. Surely the stuff that holds all of that does not come and go like guests at a party. Surely the bricks of the mind stay where they were laid. They do not. The whisper faded. And here is the number, and I want you to hold it gently because it is one of the strangest facts I know about being alive. The radioactive phosphorus content of the cerebrum of the rat decreases to 1/2 in a period of 2 weeks. 2 weeks. In the time it takes a bruise on your arm to darken and yellow and vanish, half of the phosphorus atoms in that brain had packed up and left, and half of what remained had been swapped for fresh arrivals. Wait another 2 weeks, and half of what was left goes too. The brain is not keeping its atoms, it is renting them. It holds each one for a little while, uses it, and lets it drift back out into the body, into the blood, out into the world, and pulls a new one in to take the vacant chair. Sit with that for a moment in the dark. The physical stuff of the thinking part of you is being quietly and completely exchanged over and over, while the thinking goes right on without a hiccup. You did not notice. You could not notice. The thoughts continued, the memories held, and yet the atoms carrying them were being marched out the door and replaced the entire time. Like a great cathedral where every stone is being swapped for a new one in the night, one at a time, so gently that in the morning the cathedral looks exactly the same, and is in every stone a different cathedral. And it is not only the brain. This is happening everywhere in you at once, at different speeds. The lining of your gut is one of the fastest refreshing itself in days. Your skin is flaking away and rebuilding constantly. The red cells carrying oxygen in your blood live a few months and are retired. Even your bones, which feel like the very definition of permanent, are being taken apart and put back together by patient little cells all your life. When you add it all up, when you follow every kind of atom the way they followed the phosphorus, you arrive at a fact that ought to be on the front page and never is. More than 90% of the atoms that make up your body were not in your body a year ago. They have been replaced. Through the food you ate, the water you drank, the air you pulled in and pushed out, the sweat, the waste, the carbon dioxide leaving on every exhale, you have very nearly rebuilt yourself from scratch since last summer without ever once losing yourself in the process. Now, I told you I would tell you about last week's potatoes, and I meant it, because this is where it turns from a curiosity into something that touches the bone. Think about what a memory is. It is a pattern held in the physical stuff of your brain, in the connections between cells, in the molecules that strengthen and weaken those connections. Fine. Now suppose you remember something from a year ago, a conversation, the weather on some particular afternoon, something someone said to you that you have never told anyone. That memory is real, and it is sitting in your head right now. But the atoms holding that memory today are not the atoms that were holding it a year ago. Those have long since left. So where did today's atoms come from? They came from your dinners. They came from the bread and the potatoes and the water and the air of the last several months. So it is quite literally true, and I love saying it because it sounds like a joke and is not, that last week's potatoes now remember a conversation you had a year ago. The potato atoms arrived, slid into the pattern, took up the memory that the departing atoms were carrying, and carried it on. The stuff was swapped. The pattern held. The mind that first had that thought has atom by atom been entirely replaced, and yet the thought remains, handed from one set of atoms to the next like a song passed down through a village long after everyone who first sang it is gone. So what then are you? You are not your atoms. You cannot be your atoms, because your atoms are strangers to each other across the span of a single year. They come, they do their part, they go. The thing that persists, the thing that is genuinely and continuously you, is not the material at all. It is the pattern. It is the arrangement. It is the particular dance the atoms are doing while they happen to be passing through. And the dance does not care which dancers show up tonight, so long as they know the steps. And the steps are taught, molecule to molecule, so quickly and so faithfully that the choreography never falters even as the entire company of dancers is replaced from one season to the next. I want to give you the way I have said this before, because I have never found a better way. The atoms come into my brain, dance a dance, and then go out. There are always new atoms, but always doing the same dance, remembering what the dance was yesterday. That is what you are. You are a dance. You are a shape that water keeps pouring through. And the reason this matters so much for the question we set out to answer, the question of where you go when you decompose, is that it quietly dissolves the very thing we were afraid for. We were afraid for the stuff. But the stuff was never the point, and the stuff was never staying anyway. The stuff has been leaving you and rejoining the world your whole life. Every year you have already given the great majority of yourself back to the air and the soil and the sea, and taken a fresh loan in return, and gone right on being unmistakably yourself the entire time. So when we finally walk up to death and look it in the eye, we are not going to be looking at some new and terrible event, some violation of the way things have always been. We are going to be looking at the same old river, the same endless coming and going of atoms that has defined you from your first breath, with just one small change in the arrangement. The pouring back in stops. The pouring out continues. That is all. The dancers who are passing through when the music ends simply keep walking, out the door they always used, into a world that will put them to 100,000 new uses. And to see exactly what those uses are, to follow those particular travelers out into the grass and the gas and the groundwater and watch what becomes of them, we now have to talk very calmly about what actually happens to a body once the river runs only one way. Not to frighten ourselves. Quite the opposite, because I think once you see where every kind of atom in you is headed, and how eagerly the living world is waiting to take it up again, the whole business becomes about the least frightening thing in all of physics. Let me put you at a graveside, or a hillside, or wherever it is you imagine yourself resting when the intake side finally closes. Nothing dramatic is happening yet. In the first hours and the first day or two, the body is what the people who study these things call fresh, and it is a strange, quiet word for it, because in that early stretch almost nothing looks different from the outside. But down at the level we care about, the level of the little particles jostling and tugging at one another, an enormous shift in management has just taken place. While you were alive, your own cells kept a kind of order. They spent energy every second to hold the pattern together, to keep the water where the water belonged and the proteins folded the way proteins like to fold. The moment the energy stops arriving, that policing stops. And the very first thing that happens is that your body begins, gently, to digest itself. The enzymes that spent your whole life carefully snipping molecules in the right places at the right times now go on snipping with no one telling them where or when. The cell walls soften. The tidy compartments leak into one another. This is the quietest part of the whole story, and in a way it is the most intimate, because for a little while the only thing taking you apart is you. And then the guests arrive. You have carried them your whole life. Uncounted multitudes of bacteria, mostly in your gut, living in a truce with you, fed by you, held in check by your defenses. With the defenses gone and the compartments open, the truce is over, and they spread outward through the tissues into a warm, wet, nourishing country with no borders left to stop them. Most of these particular travelers do their work without any oxygen at all, because the oxygen in the tissues is used up quickly and not replaced. We call that anaerobic, which only means living without air. And these airless workers eat in a way that produces gas. That is the key to the next chapter. They take the sugars and the proteins and the fats, all those neat molecular chains that were you, and they break them for their own energy, and out of that breaking come new small molecules that want to be gas. Methane, which is one carbon atom holding hands with four hydrogens. Carbon dioxide, one carbon between two oxygens. Hydrogen sulfide, which is where the smell begins, a little molecule of two hydrogens and a sulfur. And sulfur, you remember, came into you in your proteins, in the very amino acids that gave your hair and your enzymes their shape. Somewhere around the third to the fifth day, in ordinary conditions, all that gas has nowhere to go, and so the body swells. The people who study decomposition call this the bloat stage, and though it sounds unpleasant, I want you to see what it really is in terms of the atoms. It is your carbon, your hydrogen, your sulfur, packing themselves into the lightest, most restless little molecules they can form and beginning to press outward, looking for the exit. The pattern that held them in a hand or a thought is dissolving, and the pieces are reassembling into the simplest possible arrangements, the arrangements that gas likes best. Nature is not destroying anything here. There is not one atom fewer in that swelling than there was in the living person the week before. Every single particle is accounted for. They are merely changing partners, trading the elaborate long chains of life for short, plain, flighty molecules that can slip away into the air and the soil. There are two other travelers worth naming from this stage, because they have such wonderful names and because they tell you exactly what is going on. When the anaerobic workers get at your amino acids, the building blocks of your proteins, they perform a trick a chemist would call decarboxylation, which is a long word for a simple act. They snip off a particular little cluster, a carbon with two oxygens, and let it float away, and what is left behind is a new molecule that belongs to a family called the diamines. Two of these have been given the frank and unforgettable names purtrosine and cadaverine. And I tell you their names not to be grim, but because I love that somewhere a person looked at the molecules of decay and named them so plainly, so honestly. Those two molecules are carrying your nitrogen and your carbon and your hydrogen out of the old arrangement, and they are part of why decay announces itself to the nose of every animal for a long way around. That smell is a signal. It is an invitation. It is the living world being told, in a language older than any of us, that a great store of borrowed atoms has been returned and is now available. Come and get it. After the bloat, the pressure finds its release, and the body moves into what is soberly called active decay, and this is the stage where the greatest share of the mass simply leaves. The soft tissues, the muscle and the organs and the fat, break down and liquefy and drain away and rise off as gas, and the body loses more of its weight now than at any other time. If you want a single picture for active decay, picture a snowbank in the first warm spell of spring. Nothing is being annihilated. The snow is not vanishing. It is turning to water and running downhill and turning to vapor and lifting into the air, going where the temperature tells it to go, and by the end of the week, the shape is gone and the water is in the stream and the sky. Your active decay is that thaw. Only the snow is the elaborate architecture of your tissues, and the meltwater is a whole alphabet of small molecules trickling into the ground and drifting into the wind. How fast this goes depends enormously on the weather and the ground, and I want to give you the honest range, because it is remarkable. In real summer heat, out in the open, with the insects and the bacteria all working at full speed, a body can be reduced nearly to the bones in as few as 9 days. 9 days, and the soft architecture of a lifetime has been handed back. Bury that same body without a coffin, down in the cooler, slower dark, and the soft tissue is generally gone within about 5 years. Put it in a coffin, and the soft tissue tends to last somewhere between 5 and 10 years before it too is gone. The atoms are patient either way. Whether the handing back takes 9 days or 10 years is only a question of how warm and how open and how crowded with hungry life the surroundings happen to be. The direction never changes, only the tempo. Now I want to slow down and watch just the carbon, because carbon is worth watching all on its own, and there is so much of it. Remember the census. By weight, something like 18.5% of you is carbon, which in a person of about 70 kilograms comes to very nearly 13 kilograms of the stuff. 13 kilograms of the element that forms the backbone of every sugar and every fat and every protein and every strand of your inheritance. That is a great deal of carbon to have gathered up into one walking thinking arrangement. And where does the bulk of it go once the airless workers have had their way? It goes up. It leaves mostly as carbon dioxide, the same plain molecule you breathed out with every breath while you were alive. One carbon riding between two oxygens, rising off the ground and mixing into the general air of the planet. And here is where I have to stop you from feeling that up and away means gone. Because that carbon dioxide drifts on the wind, and somewhere, not far off, a leaf is waiting for it. Every green leaf on Earth is an engine built for exactly one purpose in this respect. It reaches into the air, it catches carbon dioxide, it takes the energy of sunlight, and it pries that molecule apart and keeps the carbon, weaving it into sugar. We call that photosynthesis, and it is the great countercurrent to all this decay, the pump that runs the other way. Your carbon, the very atoms that were lately arranged into a hand or a heart, rises as gas, meets a leaf, and is built into the body of a plant. Then, a creature eats the plant, and the carbon is built into the creature. Then, perhaps another creature eats that one. And so those particular travelers, having left you as the lightest and simplest of gases, climb right back up the ladder of complexity into living tissue again. Into a stalk of grass, into a beetle, into a bird, into the flank of a deer standing in the morning. Feynman, thinking of exactly this endless reassembly, wrote of how, deep in the sea, the molecules repeat the patterns of one another until complex new ones are formed. And they make others like themselves, and a new dance starts, growing in size and complexity into living things, masses of atoms, the long chains of inheritance and protein, dancing a pattern ever more intricate. That new dance is not a metaphor for something far away and long ago. That new dance is what your carbon does the summer after you are gone, in the field above you, in the leaves that turn to catch the light. Think for a moment about how strange and ordinary that is. All at once, a carbon atom that spent, say, 50 years locked into the enamel of your tooth, or riding along in the wall of a cell in your liver, does its little turn as a puff of gas, floats up through the crumbs of soil, catches a breeze, drifts across a field, and then a green leaf, doing the oldest chemistry on this planet, reaches out and grabs it and pins it down again into sugar. And it does not know it was ever you. The leaf does not know, the atom does not know, there is no little label on it that says where it has been. That is one of the deepest and gentlest facts in all of physics. The atoms carry no memory of their own. Every carbon atom is exactly, precisely, perfectly identical to every other carbon atom. There is no old carbon and young carbon, no tired carbon and fresh carbon, no carbon that remembers being a Caesar and carbon that remembers being a clam. They are interchangeable in the most complete way anything in this universe is interchangeable. The memory, when there is memory, is never in the atom. It is only ever in the arrangement. I want you to sit with that, because it turns the whole question upside down. When people ask where they go when they die, they are usually asking about the atoms, as though the atoms were the self. But the atoms were never the self, not even while you were alive. You proved that already, without meaning to, every single year you were breathing. You handed nearly all of them back and took a fresh set, and you stayed you the whole time. So the atom scattering into the grass and the gas and the groundwater is not the loss. The atoms were always doing that. The atoms were a river running through the shape of you, and you were the shape, not the water. Now let me follow another one of these travelers, because carbon is only the loudest of the crowd, and there is a quieter one that has a more surprising journey, and that is nitrogen. Nitrogen is a smaller part of you by count, only a little over 1 atom in 100, but it is precious, and its path out of the body is nothing like the simple upward drift of carbon. Nitrogen sits at the very heart of every protein you ever built. It is threaded into the amino acids, the little beads that string together to make the muscle and the enzyme and the hair and the collagen. When the bacteria go to work on those proteins, they crack the beads apart, and one of the first things that comes loose is a small, sharp-smelling molecule made of one nitrogen atom clutching 3 hydrogens. That is ammonia. If you have ever caught the fumes over a bottle of cleaning fluid and felt it bite the inside of your nose, you know its signature exactly. That very molecule, that same trio, is what your protein nitrogen becomes when the deamination begins, when the bacteria strip the nitrogen-bearing piece off the amino acid and let it go. And here is where nitrogen becomes a much more interesting traveler than carbon, because carbon mostly just leaves. It floats up and away, and it is done. But nitrogen gets caught in a relay race, a long chain of handoffs, and the shape of that race depends entirely on the ground it lands in. Picture the soil beneath a body as a crowd of runners, each waiting for the baton. The ammonia comes loose, and it is the first baton. If the soil is acidic, a little sour in its chemistry, that ammonia grabs an extra hydrogen and turns into ammonium, a molecule with a small positive charge, and being charged it clings to the particles of soil and stays put for a while, held close, not going anywhere in a hurry. But if the soil is alkaline instead, if it leans the other way, the ammonium lets that extra hydrogen go and slips back into being ammonia gas, and off it drifts into the air after all. So the very same nitrogen atom can either linger in the earth or rise into the sky, depending on nothing more than whether its little patch of ground is sweet or sour. Chemistry does not care about our categories. It simply tips one way or the other, and the atom follows. But the race is not over, because the soil is full of bacteria whose entire living is made from passing this baton along. One kind of bacteria takes the ammonium and, breathing with it, hands it forward into a form called nitrite. And then another kind takes the nitrite and hands it forward again into nitrate. This is the relay we call nitrification, and each runner is a different species of the invisible multitude, each one earning its keep by nudging the nitrogen one step further down the track. Nitrate is a fine and useful thing. It is exactly what a root wants to drink. So a great deal of your nitrogen, having come out of your proteins as that sharp little ammonia, gets walked step by patient step into nitrate and then sucked up into the roots of whatever is growing overhead and built once again into new protein into the green machinery of a plant, and from there into whatever eats the plant. That is the same climb back up the ladder that the carbon made, only by a longer and more crowded staircase. And there is one more runner in this relay, waiting at the far end for a different handoff, and this one closes the loop all the way back to the sky. When the ground is starved of oxygen, when it is waterlogged and airless, certain bacteria learn to breathe using nitrate instead of oxygen, and in doing so they strip it down step by step until two nitrogen atoms find each other and lock together into a molecule of nitrogen gas. That is denitrification, and it is the exit door back to the atmosphere. Now this matters more than it sounds, because the air you are breathing right now, the very air filling your chest as you lie there in the dark, is nearly 4/5 nitrogen gas. That vast ocean of nitrogen over our heads is the great reservoir, and every breath you take is mostly it, pouring in and pouring out untouched. Because those paired nitrogen atoms are bound to each other so tightly that your body cannot pry them apart. So some of your nitrogen, having been protein, having been ammonia, having been walked through nitrite and nitrate by a parade of bacteria, finally pairs up and rises and joins that ocean in the sky and waits there, patient as anything, for the rare lightning strike or the slow work of a root nodule to draw it back down into life again. Years or centuries from now. Do you see how much busier nitrogen is than carbon? Carbon takes the express. Nitrogen takes every local stop, changes trains a half dozen times, gets held at the platform when the soil is sour, and rides out on a completely different line depending on who is running the station that day. And all of this is happening in the top few inches of dirt, in the dark, silently, without any drama at all in the ordinary economy of the ground. And it leaves a mark. This is one of the facts I find quietly astonishing. A decomposing human body puts something like 32 grams of nitrogen into the surrounding soil for every kilogram of its dry mass. That is not a trace. That is a flood, by the standards of soil. The ground beneath does not simply forget you. The chemistry of that patch of earth is measurably changed, and it stays changed, not for a day or a season, but for years. If you knew exactly what to test for, you could read the shadow of a body in the soil long after the body itself was gone, in the raised levels of nitrogen and the way the plants above grow greener and ranker for a time. The nitrogen and phosphorus in that grave soil climb to their highest point by about the 20th day after death, a sharp peak in the chemistry of the ground, and then they begin their long dispersal outward, into roots, into runoff, into the slow bacteria relays I have been describing. A body is a slow fertilizer. That is not a grim thing to say. It is simply what the atoms do. They enrich the exact ground they are given to. Now I have mentioned phosphorus twice now, riding alongside the nitrogen, and it deserves its own moment. Because phosphorus is a peculiar and important atom, and it does not behave like the others at all. It does not have a gas to escape into. Carbon has its carbon dioxide, nitrogen has its ammonia and its nitrogen gas, and both of them can take to the air and travel the whole wide world on the wind. Phosphorus cannot. Phosphorus has no convenient vapor, no easy breath to ride. It is a homebody. When it comes loose from you, it stays low, it stays local, it sinks into the ground right where you lie, and mostly it remains there, working its way into the soil and the roots and the water table close by. About 10 grams of it per kilogram of dry body mass seeping into the earth right there, staying near. And yet phosphorus, for all that it stays close, is one of the most important atoms you own, because without it there is no life at all. Not anywhere, not of any kind we know. Remember that experiment I told you about, the one with the radioactive phosphorus in the rat's brain? The atoms cycling completely out in a couple of weeks. That was phosphorus precisely because phosphorus is at the beating center of what a living thing does. It is in the molecule your cells use to carry energy from where they make it to where they spend it. The little rechargeable battery that every cell in you passes around billions of times a day. And it is in the backbone, the literal structural spine, of every strand of the long inheritance molecule coiled up inside every one of your cells. Every rung of that spiral staircase is held up by phosphorus. So the atom that will not fly, the atom that stays humbly in the dirt beneath you, is the very atom that spelled out the instructions for building you in the first place, and for building every ancestor you ever had all the way down. And so the picture I want you to hold is this. The atoms that carried your fire, the phosphorus that flickered energy from cell to cell, do not go up into the sky with the rest. They sink. They stay near. They wait in the ground like patient guests who never leave the party, and in a spoonful of the soil beneath a resting body you will find, for years afterward, 10 grams of phosphorus for every kilogram of the dry stuff that person once was. 10 grams. It does not sound like much when I say it plainly. But remember what phosphorus does. A single one of those atoms once sat at a rung of the staircase that held the whole plan of a human being. Now it sits in the dirt, and a root will find it and lift it and thread it into a rung of some new staircase, in some new green thing reaching for the light. The plan does not die. The letters get reused. Let me stay down there in the ground with you a while longer, because the last thing to leave is the most stubborn, and it tells the best story. The soft parts of you are in a way easy. Water pours off, fat and protein are feasts, and there is no shortage of hungry mouths too small to see. But the frame, the scaffolding, the 200-odd bones that gave you a shape to walk around in, those are built to last, and they resist. A bone is a clever thing. It is two materials married together. There is a protein, a tough springy rope of a protein called collagen, woven all through it, and packed around that rope there is a hard mineral, a crystal of calcium and phosphorus that chemists call hydroxyapatite. Put a soft rope inside a hard stone, and you get something that neither bends too easily nor shatters too easily. That is why you can fall and get up again. That marriage is the whole trick of bone. To take a bone apart, you have to break the marriage, and it takes two very different kinds of patience to do it. The living rope, the collagen, is food, and there are bacteria that carry a special pair of scissors, an enzyme built for exactly one job, snipping collagen into pieces small enough to eat. Snip by snip, over months and years, the rope is cut and carried off atom by atom into the small bodies of the things that did the cutting, and out again when they in turn are eaten or die. And once the rope is gone, the stone is left standing alone, brittle, unsupported. Now the second kind of patience takes over, and it is not alive at all. It is only water, and whatever the water carries. If the soil is sour, acidic, rich with the acids that fertile living earth makes, then the water quietly eats the stone. It dissolves the crystal. It lifts the calcium away as free-floating ions, drifting off into the groundwater, and in ground like that, a whole human skeleton, the entire architecture of a person, can be gone, wholly dissolved in about 20 years. 2 decades, and the frame itself has joined the flow. But change the ground, and you change the ending entirely. Put that same skeleton in soil that is neutral, or sandy, or dry, and the water has no appetite. There is nothing to dissolve the crystal, and so it stays. Bones like that can wait in the earth for hundreds of years, and this is exactly why we can dig up a person who lived a very long time ago and hold their thigh bone in our hands, and it is also why in other places we dig and find nothing at all, not a trace, though we know someone was laid there. The soil wrote the ending. The very same body, the very same atoms, get a fast exit or a slow one depending only on the chemistry of the dirt they happen to lie in. Nature is not sentimental about it. She keeps no fixed schedule. In the heat of summer, above the ground, exposed, a body can be reduced to clean bone in as few as 9 days. Buried without a box in ordinary earth, the soft parts are usually gone within about 5 years. Sealed in a coffin, slowed but not stopped, the soft tissue takes something more like 5 to 10. And the bones outlast all of it, the last holdouts, the final delegates of the pattern, standing their ground until the water, sweet or sour, decides their fate. Now I have taken you all the way down through the bloating and the gases, down through the liquefying and the leaching, down to the last dissolving crystal of the last bone. Every atom accounted for, more or less. The light ones flew, the carbon rose as gas, the nitrogen ran its bacteria relay, the phosphorus stayed to feed the roots, the calcium drifted off in the groundwater. And you might think that is the end of the accounting. The body is gone. Case closed. But it is not the end. It is barely the middle. Because I have only told you where the atoms leave from. I have not told you where they go. And that, if you will stay awake with me just a little longer in the dark, is where the whole thing turns from a story about death into a story about everyone who has ever lived. Let me start with a single breath, and one very famous last one. There is a man, dead now more than 2,000 years, who was, on a certain afternoon in Rome, rather dramatically stabbed. And in the shock of that, he did what any of us does, what you are doing right now without thinking about it, without deciding to. He took a last breath, and then he let it go. Now I want you to think about that final exhalation as a physicist thinks about it, which is to say, I want you to count it. That breath, that last warm cloud of air leaving his lungs, held a certain number of little molecules of gas. Not a small number. Roughly 25 sextillion of them. Let me say that as the digits would be, in words. A 25, and then 21 zeros trailing off behind it. 25,000 billion tiny molecules released in a single sigh. That sounds enormous. And it is. But now I have to tell you about the thing that swallows even numbers like that and makes them feel small. The atmosphere. The whole ocean of air wrapped around this planet. The air over every desert and every sea and every mountain nobody has ever climbed. Its volume is something like 5 times 10 to the 18th cubic meters. Say that as a 5 with 18 zeros after it, a number so large the words for it start to lose their grip. And here is the fact that changes everything. Air moves. It does not sit still. The winds do not respect borders. They do not stay in one country. They do not honor the grave. Over the space of a year or two, the winds of the whole planet stir the entire atmosphere together, top to bottom, pole to pole, until whatever was released in one place is smeared evenly through all of it. 2,000 years is a very long time to stir. That last breath from that Roman afternoon has been mixed and mixed and mixed again, 10,000 times over, until its 25 sextillion molecules are spread out thin and even across the entire sky of the entire Earth. So now, ask the question that a child would ask, which is the best kind of question. When I breathe in, right now lying here, do I get any of them? Do any of the very molecules that man breathed out on the last day of his life come into my lungs on this ordinary quiet night? Let us just work it out. It is not hard, and I promise not to rush you. You take a breath, an ordinary breath, and it holds something like 1 1/4 times 10 to the 22nd molecules. Bigger than his breath, actually, roughly 12.5 sextillion. Now you take his 25 sextillion molecules spread evenly through the whole sky, and you ask what fraction of the whole sky one lungful catches, and you multiply. And the arithmetic, when the dust of the calculation settles, comes out to something close to 1. About 1 molecule. On average, in every single breath you draw, 1 molecule that was once inside that dying man riding out on his final sigh. 1 does not sound like many. But think about what it means that the average is even close to 1 and not close to 0. It means that breath after breath, all day, all night, without ceasing, you are pulling in the exhaled air of the long dead. And if you ask the sharper question, not how many on average, but simply whether you get at least 1 on any given breath, the odds come out to about 99.2%. 99 breaths out of 100 contain a piece of that one particular ancient afternoon. Not a metaphor, not a poem, just counting. The air you are breathing in the dark as you drift towards sleep has been breathed before by everyone, and it will be breathed again by everyone who comes after, and the sky keeps no secrets and holds no one apart. The boundary you thought was there between the air that is you and the air that is the world was never really a wall. It was only a turnstile always spinning, letting everyone through. Let me take you from the air into the water, because the air was only the beginning of the accounting. The sky is enormous, but it is not the biggest reservoir your atoms have to swim in. The ocean is. And there was a fellow, a poet, who died a good long while ago in a little English town, and I want to use him the way I use Caesar. Not because he is special, but precisely because he is not. He breathed, he ate, he sweated on warm afternoons, and in the end he did what we are all going to do. He came apart into his atoms and handed every one of them back. Now somebody sat down and did the sum for this poet, the way you would tally a grocery bill, slowly, line by line. Over the whole span of his life, breathing out, giving off waste, and then finally decomposing and releasing the last of himself, this one man let go of about 7 times 10 to the 30th atoms. Say that number gently to yourself in the dark. 7, followed by 30 zeros. It is a number so far past imagining that the imagining is not even the point. The point is that it is a finite number. It is countable. It is not infinity. And that finiteness is what makes the next step possible. Where did those atoms go to mix? Into what pot were they stirred? Not just the air this time, but the whole reachable skin of the planet. The oceans mostly, because the oceans are where the water is, and water is where most of the loose atoms of the world are kept. If you add up the ocean, and the top of the ground, and the atmosphere, all the places a wandering atom can actually get to and be picked up again by something living, you land near 1.4 times 10 to the 47th atoms. That is the size of the mixing bowl. That is how much stuff there is to dilute one man into. So here is the division, and it is the same shape of division we did with the breath. You take the atoms he released, 7 times 10 to the 30th. You take the size of the bowl, 1.4 times 10 to the 47th. You work out what fraction of the whole world is, so to speak, made of him. It is a tiny fraction, a speck of a speck. And then you ask how many of his specks would end up inside one human body, and a human body is about 4 times 10 to the 27th atoms. You multiply the fraction by the size of a person, and the answer that falls out of the arithmetic is about 2 times 10 to the 11th. 200 billion. Sit with that a moment. Not 200, not 200,000. 200 billion atoms in you right now, in the hand resting on the blanket, in the slow muscle of your heart, that once were arranged into that one particular poet. And I did not choose him because there is anything magic in his bones. I chose him because we happen to have run the numbers. Pick any person who lived a full life and died a few centuries back with time enough to mix, and you will get roughly the same helping. 200 billion from this one, 200 billion from that one, from the queen and from the beggar in the same gutter, from the general and from the child who never got a name in any book. You are carrying a fistful of every one of them, and the fistfuls stack up, and there is no bottom to the pile. And do not imagine this is only a debt you owe to the dead. The living are in you too. Each of us walks around holding, on the average, hundreds of billions of atoms that were sitting inside every other person alive on the earth as recently as 1 year ago. The stranger on the far side of an ocean you will never cross exhaled a carbon atom 2 summers past, and a plant drank it, and you ate the plant, and now that atom is filed away in the wall of one of your cells. You have never met, and you never will, and yet you are, in the most literal and unpoetic sense, partly made of each other. We are passing ourselves around constantly, hand to hand, lung to lung, without a single one of us ever deciding to. The trade goes on whether you consent or not, whether you notice or not, whether you are awake or, as I hope you are becoming, pleasantly close to sleep. Now I want to press on the boundary a little harder because I think there is still a part of you that resists. There is still a part that says, all right, atoms come and atoms go, but surely at the bottom of it there is a me, a kernel, some private stock of matter that is mine and stays mine and makes me myself. And I am sorry to be the one to tell you, but when you actually go looking for that kernel, it is not there. It was never there. Run the clock forward just 1 year past a person's death and ask a simple question. Take any specific individual who has died. Pick one atom of hydrogen in your body at random. What are the chances that this particular hydrogen atom came from that particular person? The answer is about 1 in 2.1 times 10 to the 16th. 1 in 21,000 trillion. Almost none. And yet, and this is the thing that undoes the whole notion of a private self, when you add up all those almost nones across every atom in you and every person who has ever lived, the sum comes out to those enormous helpings I just gave you. You are made almost entirely of almost nobody, and the almost nobodies together are everybody. So where is the wall? Where is the edge of you? While you were alive, it was never a wall. It was a turnstile spinning day and night. More than 9 out of every 10 of your atoms swapped out for fresh ones every single year. The potatoes of last week reporting for duty as brain. The water you drank this morning already leaving as breath and sweat. You were a fountain, not a stone. Water thrown up into a shape and held there by the throwing. And death, when it finally comes, does not smash the fountain. It only turns off the pump that was pushing new water up. The shape you were sinks back down into the pool it was always standing in. The atoms do not go anywhere strange. They go back to the exact reservoir they were borrowed from, the reservoir they had been quietly commuting to and from your whole life long. Death does not break the connection between you and the world. It removes the illusion that there was ever a separation to break. And I find, when I turn this over in my hands, that it is not cold at all. People expect it to be cold, this atom's only way of looking. They think if you take away the wall around the self, you take away something precious. But look what you get instead. You get to be unlosable. Not you, the pattern. The pattern does end. I will not lie to you and say the dance goes on when the dancer stops. The dance stops. But the dancers, every last atom of them, cannot be destroyed, cannot be spent, cannot be used up. They are the most durable thing there is. They were here before the sun had a name, and they will be here shuffling into new arrangements long after. And so the same oxygen that is, at this instant, folding into the shape of your breathing was once folded into the shape of a fish, and a fern, and a falling raindrop, and a person who is frightened of the dark just as you sometimes are, and it will be folded after you into a root, a wing, a wave, and a child not yet conceived. This is what those old lines about the sea were reaching toward. Deep in the water, the same atoms line up and copy one another and copy the copies until something complicated enough to make more of itself flickers into being and a new dance starts. Growing, getting more tangled and more clever, sheets of protein, ladders of the stuff that carries the pattern down the generations, all of it a rhythm played on the same handful of elements over and over. It is not that your atoms will one day rejoin life. They never left it. They are simply on loan to you for a little while, and when the loan is called, they will step out of your dance and into the next one without so much as a pause between the songs. You are a verse. The atoms are the alphabet. And the alphabet gets used again. Let me take you somewhere with this, Because it is one thing to say the atoms are on loan and quite another to follow one of them out the door and watch where it goes. So pick a single carbon atom. It was in you, in the soft gray folds where you did your thinking, and now, some weeks after the dance in you has stopped, a small patient bacterium has pried it loose, hooked it to two oxygen atoms, and set it free as a puff of carbon dioxide. Up it drifts through the crumbs of soil, out into the open air. And here is where the story gets almost too large to hold in the head, so we will go slowly, and we will do a little arithmetic together. The gentle kind. The kind you can do lying down with your eyes closed. The air over your head is not a small thing. If you could weigh the whole blanket of atmosphere wrapped around this planet and measure out the room it takes up, you would find something like 5 times 10 to the 18th cubic meters of it. That is a 5 with 18 zeros trailing behind, a number so far past anything you have ever counted that it stops meaning much. So let us not try to feel its size directly. Let us instead do what a physicist always does when a number is too big. We compare it to another big number, and we let the two monsters fight it out, and what falls out of the fight is something small and human that we can actually understand. Here is the comparison I love, and it is an old one. Older than me. Imagine a man dying a very long time ago. Let us say 2,000 years ago, more or less, a famous fellow stabbed in a hall full of people who used to call him friend. In his last moment, he lets out one final breath. Now that breath is just air, ordinary air, the same stuff you are breathing this very second. And in that one breath there are, let me tell you the count, somewhere around 25 times 10 to the 21st molecules. 25 sextillion tiny things tumbling out into a Roman afternoon. Now here is the question that seems at first a little morbid and a little silly. Over all these centuries that breath has spread. The winds took it. The molecules wandered north and south over oceans, over deserts, up into the high cold streams of air and back down again. 2 years, roughly, is all it takes for a puff of gas to smear itself more or less evenly around the entire globe. And it has had far more than 2 years. It has had 2,000 of them. So by now those 25 sextillion molecules are sprinkled through the whole vast 5 times 10 to the 18th cubic meters of atmosphere, thin as a rumor, everywhere at once. And the question is this. When you take your next breath, how many of those exact molecules, the ones that man exhaled as he died, do you pull into your own lungs? Most people, when you ask them, guess 0. They guess that surely, across all that time and all that emptiness, not one of his particular molecules could possibly find its way into one particular breath of yours. It feels obvious. It feels like common sense. And it is completely wrong, and I can show you why in a way that will let you check it yourself. The trick is to think of it as a ratio. His breath was 25 sextillion molecules poured into an ocean of air. Your breath is a dip of a cup back into that same ocean. Your single breath, by the way, holds about 1.25 times 10 to the 22nd molecules, which is even a touch bigger than his was. So how many of his are in yours? You take the number of his molecules, spread through all the air, and you figure out what fraction of all the air your one breath scoops up, and you multiply. The molecules in his breath, divided by all the molecules in the whole sky, times the molecules in your breath. When you turn the crank on that arithmetic, the enormous numbers on top and bottom do their fighting, the zeros cancel against zeros, and what tumbles out at the end is small and quiet and astonishing. Roughly 1. About 1 molecule in every breath you take was once the final breath of a man who died 2,000 years ago. Sit with that for a moment, softly. Not a metaphor, not a poem, a count. One of the actual particles that carried the last of the air out of his chest is on average right now inside your chest. And the next breath brings another. And the one after that, another still. If you work out not the average but the odds, the chance that any given breath of yours contains at least 1 molecule from his dying exhalation comes out to about 99.2%. Better than 99 times in 100. You are essentially always breathing him. You cannot help it. The air remembers everyone. I want you to notice why this works. Because the reason is the whole secret of this entire talk. It works because atoms are absurdly ridiculously small, and because there are absurdly ridiculously many of them. Those two facts pull in opposite directions, and where they meet is this strange middle country where a single dying breath can reach across 2,000 years and touch every person alive. The bigness of the number of atoms in one breath is almost as big as the bigness of the whole sky. Not quite, but almost. And that little gap between them is measured in single molecules landing in single breaths. That is the arithmetic of dispersal. That is where your atoms are going, and it does not stop at breath. Let me take you to another fellow, a poet this time dead about 400 years, a man who wrote plays. Over the span of his whole life he did what all of us do. He breathed in and out for decades. He sweated. He shed. He let go of waste the way a living thing must. And at the end he decomposed the way we all will, every atom in him handed back. Add all of that up, every atom he loosed into the world across a lifetime and a death, and you get a colossal figure, something like 7 times 10 to the 30th atoms set free. 7 followed by 30 zeros. Now those did not vanish into the sky alone. Many went into the water, into the great churning reservoir of the oceans and rivers and rain, which is where most of the reachable atoms on this planet actually live. The whole accessible store of atoms you might trade with, the air and the water and the thin living skin of soil, comes to something like 1.4 times 10 to the 47th atoms. That is the pond. His lifetime's contribution is the drop. And you, a human body, are made of roughly 4 times 10 to the 27th atoms drawn from that same pond. So we play the same game. His drop, spread through the whole pond, sampled by your body. Turn the crank, let the giants wrestle, and out falls a number that I find hard to say without smiling. About 200 billion, 2 times 10 to the 11th. Every person walking around today carries, on average, something like 200 billion atoms that were once assembled into that one poet. His hand held a pen with atoms that are now scattered, a few 100 billion each, through every living human being on the face of the earth. You have some. The stranger beside you has some. A child born tomorrow will have some. And it is not only the famous dead. That is just where we point the arithmetic, because the names make it vivid. The truth is broader and stranger and warmer than any single name. Run the same calculation on everyone, and it turns out that each of us is carrying right now hundreds of billions of atoms that were sitting inside every other person alive on this planet just 1 year ago. Every other person. The ones you love, the ones you have never met, the ones on the far side of an ocean you will never cross. A year ago, some scattering of the atoms now doing the dance in you was doing a different dance in them. And a year from now, some of yours will have moved along into someone else. We are not separate vessels passing in the dark. We are one slow, shared, sloshing sea, endlessly trading pieces, and we simply move too slowly, and the pieces are simply too small for us to ever feel the current. That is the thing the old fear misses. When a person imagines their own decomposition, they picture a scattering, a coming apart, a loss, atoms flung out into nowhere and lost. But nowhere is not where they go. There is no nowhere. Every atom you release lands somewhere real, somewhere counted, somewhere it can be found again by exactly this arithmetic. It goes into a breath. It goes into a raindrop. It goes into a leaf uncurling on a branch, into the muscle of a running animal, into the blood of a person laughing at a joke 100 years after you are gone. The dispersal is not a disappearance. It is a distribution. You are not scattered to the void. You are handed around. Let me sit with that phrase a moment, because it does some quiet work. Handed around. It is a gentler verb than most people reach for when they think about the end. And it is not a comforting lie, it is just the accounting. When you hand something around a room, nobody says the thing was destroyed. They say it went from one pair of hands to the next. The cup of atoms that was briefly labeled with your name gets tipped and it pours, and the pouring is slow. So slow you could watch it your whole life and never see the level drop, but it pours all the same, and it fills other cups, and those cups have names too for a while. Now I want to press on the idea of the boundary a little harder, because I think it is where the old fear actually lives. The fear is not really of atoms moving. The fear is of a line being crossed. There is a line we feel around a person. Inside the line is me. Outside the line is everything else, the world, the air, the dirt, the other people. And death, we imagine, is the moment the line is erased, the fortress wall coming down, the inside spilling out into the outside where it does not belong. That is the picture. And I want to tell you that the picture is wrong in a way that is almost funny once you see it. The line was never a wall. It was never even a fence. If you could stand at the surface of a living body and watch the traffic across that supposed border, you would not see a barrier at all. You would see a doorway with no door in it and a crowd going through in both directions every second of every day. Think about what your skin is actually doing right now, in the dark, while you lie there. It is leaking water into the air as vapor, molecule by molecule, and you never feel it. It is shedding, constantly, tiny flakes of itself, carrying away carbon that a week ago was inside you and is now dust on a windowsill. Every time you breathe out, you are exporting carbon, real carbon, 12% of you by count, riding out on carbon dioxide, gone into the room, into the sky. Every time you breathe in, you are importing oxygen atoms that this morning were dissolved in a wave somewhere, or locked in a leaf, and now they are diving into your blood, threading through the finest vessels, being handed to a muscle, becoming, for a little while, unmistakably you. The border you imagined was a solid thing is the busiest intersection in the world, and it never closes, and there is no God, and there never was. So here is the thing I find genuinely startling, and I have thought about it a great deal. The one and only difference that death makes to this whole picture is a matter of direction. That is all. While you live, the traffic runs both ways. Atoms in, atoms out, in, out. A merchant at a stall taking coins and giving change all day long. The till always full, because the flow never stops in either direction. When you die, the merchant stops taking coins. The giving continues. The change keeps going out. Nothing new comes in. The two-way street quietly becomes a one-way street. That is the whole of it. Not a wall coming down, not a scattering into nowhere. Just one lane of a road that was always open, closing, while the other lane keeps carrying its slow traffic out into the world for years and years. And you can measure how faint that outward traffic becomes, how thoroughly it thins into the general sea, and the number is one of the strangest I know. Take a person who died. Any person. A year after they have gone, ask how much of them is left as a recognizable signal inside your own body, inside the body of someone who was alive at the same time and shares this atmosphere and this water. The answer for hydrogen, the most common atom in you by far, is about one atom in every 21,000 trillion. Let me say that number more slowly, because it is worth feeling its size. 1 in 2.1 times 10 to the 16th. That is 1 in 21 million billion. It is a needle not in a haystack, but in a mountain range of haystacks stretching past the horizon. And yet, and here is the beautiful part, it is not zero. It is not 1 in infinity. It is a real, finite, countable fraction, which means the atoms are genuinely there, in you, threaded through your tissue, a person you may never have met leaving a signature so faint no instrument on earth could pick out which atoms they are, and yet the arithmetic swears they are present. Present, but unfindable. Everywhere and invisible. That is not disappearance. That is what perfect mixing looks like from the inside. I want you to notice how different this is from the way we usually talk about being remembered. We say a person lives on in memory, in the minds of those who love them, and that is true and it is precious, and it is also fragile, because memory fades and the people who remember also die, and after 100 years or 200 the memory is gone entirely, the name unspoken, the face unimagined by anyone. But the atoms do not fade. They do not require anyone to hold them in mind. They keep circulating whether or not a single soul recalls the person they once composed. 2,000 years after a man drew his last breath in a marble hall, we can still calculate, to a decent approximation, that a piece of that very breath is in the lungs of a child on the far side of the world tonight. The mind's memory is a candle. The atomic memory is the wax, and the wick, and the smoke, and the warm air rising, all of it conserved, none of it lost, just rearranged into the next flame and the next. Now let me be careful and honest the way I like to be, because I do not want to oversell this and hand you a warm feeling built on a fib. When I say a piece of you goes into a leaf, into a running animal, into the blood of someone laughing a century from now, I am not saying your thoughts go there. I am not saying your love, your jokes, your particular way of tilting your head, ride along on the carbon. They do not. The atom carries no cargo of memory. A carbon atom that spent 40 years in your hand and is now inside a sparrow does not know it was ever in a hand. It never knew anything. It is a carbon atom, identical to every other carbon atom in the universe, utterly without history as far as it is concerned. What was you was never the atoms. It was the pattern. It was the dance the atoms were doing while they were passing through. And when the dance stops, the dancers do not stop. They just leave the floor, one by one, and go find other music. That distinction is the whole ball game, and I want to make sure it is sitting comfortably in your mind before we go further, because everything gentle about this depends on getting it right. If you thought you were the atoms, then their dispersal would be your annihilation, and the fear would be exactly correct, and no arithmetic could soothe it. But you are not the atoms. You never were. You are a process the atoms were briefly caught up in, the way a whirlpool is a shape the water is briefly caught up in. You can point at a whirlpool. You can name it. You can watch it for an hour and say, there it is, the same whirlpool. And yet not one drop of water stays in it from 1 second to the next. The water pours through. The whirlpool remains, made of nothing but the pouring. And when the river flattens out and the whirlpool goes, you do not mourn the water. The water was never lost. It flows on downstream, every drop of it, into the next bend, the next fall, the next slow pool where perhaps another world begins. You are the whirlpool. You have always been the whirlpool. The radioactive phosphorus in that rat's brain told us so decades ago in a quiet laboratory result that most people never heard and that shook Feynman enough that he wrote it down and never let it go. Half the phosphorus in a brain gone and replaced in 2 weeks. The dancer changes while the dance holds its shape. Last week's potatoes doing this week's remembering. If you truly were the stuff you are made of, you would already have died 100 quiet deaths in your lifetime, every time a batch of atoms cycled out, and you would never have noticed a single one. Because the pattern rode smoothly across the change, unbroken, humming along on borrowed material the whole way. So when the final change comes, the one we have been circling all this time in the dark, understand what is and is not happening. What is happening is the same thing that has been happening every day of your life. Atoms leaving. What is not happening, for the first time, is the replenishing. The dance winds down not because the dancers are seized and taken, but because the choreographer sets down the baton and stops calling the steps. The dancers, released, simply wander off the floor and out into the wide warm night, still perfectly good dancers, carrying nothing, remembering nothing, ready for whatever music plays next. And somewhere out there in the sloshing shared sea we have been counting all evening, the music is always playing, and it is always in some new corner, just beginning. Let us follow them then, these released dancers, and see where the music takes them, because it is a far more orderly departure than you might guess from the outside. For a little while after the final change, nothing much happens at all. The atoms are still arranged in the old shapes, the proteins still folded, the cells still stacked in their tissues like bricks in a wall whose mason has simply walked away. But a wall without a mason is a wall that has stopped being maintained, and maintenance, it turns out, was the only thing holding back an army that was inside you the whole time. Here is a thing that surprises people, and it surprised me when I first sat with it. The great dismantling is not done by strangers. It is done, in its first and busiest chapter, by your own tenants. All through your life, your gut carried a teeming population of bacteria, more of them by count than you have cells of your own, and while you lived, they kept a polite arrangement. You fed them, Your defenses fenced them in, and they stayed where they belong. When the pattern stops calling the steps, the fences come down, the oxygen that once flooded your blood stops arriving, and those bacteria find themselves in a warm, still, oxygen-poor country with an endless larder and no borders at all. So they do what any living pattern does. They eat, and they multiply, and they spread outward from the belly through the tissues, and the second dismantling begins from the inside. Around the third to the fifth day, in ordinary warmth, you reach the stage the people who study these things rather bluntly call the bloat. The bacteria, working without oxygen, cannot burn their food cleanly the way you and I burn ours with every breath. They ferment it instead, and fermentation is a messier fire. It throws off gases. Methane, that same light gas that hisses from a kitchen stove. Carbon dioxide, the very gas you have been breathing out your whole life, and hydrogen sulfide, the gas that gives rotten eggs their unmistakable announcement. These gases have nowhere to go. They are made deep in the tissues, and so they gather and they press outward, and the body swells. That is the whole of the mystery of the bloat. It is nothing but the exhaust of a billion tiny fires trapped, looking for the door. And already, you see, the great redistribution has quietly started. That carbon dioxide is carrying carbon atoms. Your carbon, the carbon that a moment ago was folded into your muscle. That methane is carrying more of it. 4 hydrogen atoms riding along on each carbon like children on a cart. The hydrogen sulfide is carrying sulfur, the sulfur that used to knit your proteins together at their folds, the little stitches that gave them their shapes. Every gas is a departure. Every bubble that presses against the swelling skin is a small crowd of your atoms buying their tickets, and the destinations printed on those tickets read simply everywhere. Then comes the stage they call the active decay, and it is the loudest chapter in the whole quiet book, if we can call anything about this loud. The tissues, held together by proteins that are now being unstitched wholesale, lose their structure and turn to liquid. This is when the body loses the most of its mass the fastest, when the greatest bulk of you leaves in the shortest time, and out of the chemistry of it come compounds with names that sound almost comic until you understand what they are telling you. Putrescine, cadaverine. They are built when the bacteria take the amino acids, the building blocks of your proteins, and snip off a particular piece. A little cap of carbon and oxygen, and what remains is a small potent molecule that carries away nitrogen on a spine of carbon. The names are ugly on purpose. But look at what they actually are. They are your protein, taken apart with care, its precious nitrogen packaged up and handed to the soil. Nothing is wasted. Nothing is destroyed. It is all only handed onward, molecule by molecule, into the next set of hands. Now let me slow us down and follow a single element out the door, because the carbon story is the grandest of them all, and it deserves to be walked, not rushed. You are by weight nearly a fifth carbon. In a body of 70 kilograms, that is something close to 13 kilograms of pure carbon, 13 kilograms of the very element that makes coal black and diamonds bright and every living thing on this planet possible. Where does 13 kilograms of carbon go? Most of it goes up. It leaves, atom by atom, riding out on carbon dioxide, the same 3-atom molecule, 1 carbon with 2 oxygens on its arms, that has been flowing out of your lungs with every breath since your first. In life you exhaled it. In the great change you exhale it still. Only now the breathing is done for you by the bacteria and the slow chemistry of the soil, and it seeps up out of the ground instead of out of a chest. It rises. It mixes into the air, and there it joins the single most restless pool of atoms in the whole world above the ground, the atmosphere, that thin shell of gas that the winds stir and fold and carry from pole to pole in a matter of a couple of years. And here is where the tale turns, quietly from an ending into a beginning. And I want you to feel the turn. That carbon dioxide, your carbon dioxide, drifts on the wind until one afternoon it settles against the underside of a leaf. Now a leaf is a machine, a green machine of exquisite patience, and its one trade is this. It takes carbon dioxide out of the air, and it takes the light of the sun, and it takes a little water drawn up from the roots, and it welds them together into sugar. It pries the carbon loose from its two oxygens, and it stitches that carbon into a ring, and the ring is food, and the food is the leaf, and the leaf is the plant. Your carbon, that was muscle, that was for a while a gas seeping out of the dark ground, is now built into a growing green thing reaching up toward the light. And then, of course, something eats the plant. A deer, a caterpillar, a cow, a child biting into an apple. And the carbon that was yours, that was the leaf's, becomes the deer's, becomes the caterpillar's, becomes the child's. And in that new body it may become muscle again. Muscle in a creature not yet born when you set it free, muscle that will run across a field under a sky your carbon has by then crossed 100 times. This is not poetry that I am dressing up to comfort you. This is bookkeeping. This is the plain arithmetic of where the atoms are, tracked from one address to the next, and the arithmetic simply happens to read like the older story we tell. I put it to you the way I have carried it in my own mind for a long time. Deep in the sea, and deep in the soil, and deep in the still air, all the molecules repeat the patterns of one another, until complex new ones are formed, and they make others like themselves, and a new dance starts. That is not a metaphor I reach for to soften the subject. It is the literal machinery of the living world. Your atoms do not retire. They do not sit in an urn of finality doing nothing forever. They are pulled, almost at once, into the next round of pattern making, into the next green leaf, the next small animal, the next dancer stepping onto the floor as the music, which never actually stopped, swings back around to a beat it seems to remember. So let us hold the carbon there for a moment, riding into a leaf, and turn to follow the nitrogen, because the nitrogen takes an entirely different road out of you, a slower and stranger and more crowded road, and to walk it we have to meet the relay runners of the soil, a whole succession of bacteria who each carry your atoms only a short way before handing them, gasping, to the next. It is one of the most beautiful chains of chemistry in all of nature, and hardly anyone ever thinks to look at it. But we have all night, and the ground is patient, and the nitrogen is in no hurry at all. Now the nitrogen inside you is a curious kind of prisoner. It has spent your whole life locked into the middle of things, into the amino acids that string together to make your proteins, buried in the folds of muscle and enzyme and the little machines that read your genes. Nitrogen almost never travels alone in the body. It is always clasped between carbons and hydrogens held in the heart of a molecule doing quiet structural work. And when the pattern that held it together comes apart, when the proteins that made you begin to unravel under the patient chemistry of bacteria, the nitrogen has to be pried loose, one atom at a time. The first step is a thing the chemists call deamination, which is a long word for a simple act. A bacterium comes along and clips the nitrogen-bearing piece off an amino acid, and what floats free is ammonia. Now ammonia is one nitrogen atom holding hands with three hydrogens, and it is sharp and it is restless and it wants to be gone. If you have ever caught a whiff of a cleaning bottle and felt it bite the back of your nose, that is the very same molecule, and something very like it is what rises, faint and invisible, from the soil above a body that has begun its long unmaking. So already, your nitrogen has changed costumes. It came out of a protein which was solid and folded and specific to you, and now it is a small gas, anonymous, indistinguishable from the ammonia that ever came off any creature that ever lived. But here is where the road gets crowded, and here is where the relay begins. That ammonia does not simply drift up and vanish into the sky. It lands in the soil, and the soil is not dead. The soil is the most densely populated city in the world. In a single handful of ordinary garden earth there are more bacteria than there are people on the whole face of the earth, and every one of them is hungry. And a great many of them are hungry for exactly the kind of chemistry your nitrogen is now offering. What happens next depends a little on the mood of the ground. If the soil is sour, if it is acidic, the ammonia grabs an extra hydrogen and becomes ammonium, which carries a small electric charge, and so it clings, it sticks to the little grains of clay and holds still. If the soil is sweet, if it is alkaline, the ammonium loosens back into ammonia and lifts off again as gas. So your nitrogen breathes. in a manner of speaking. It ducks down into the ground and rises up out of it, back and forth, depending on the chemistry around it, like a swimmer bobbing between the surface and the shallows. And then the relay runners arrive in earnest. There is a family of bacteria whose whole living is made by eating ammonium and breathing out something called nitrite. They take your nitrogen and they change its clothes again, and they pass it, exhausted, to the next runner. Because there is a second family, waiting just downstream, whose entire trade is to take that nitrite and work it one notch further into nitrate. Each of these little creatures does only its one step. Neither of them could do the whole job. It is exactly like a bucket brigade at a fire, where no single person carries the water all the way from the well to the flames. One hands to the next, and the next, and the next, and the water travels a great distance while no single pair of hands travels very far at all. Your nitrogen atom is the water in that bucket. It passes from mouth to mouth down a line of organisms so small you would need to magnify them thousands of times to see them wriggle, and each one takes your atom only a short way before letting it go. I want you to sit with how strange and lovely that is. When you were alive, the nitrogen in your proteins was, in a sense, yours. It was arranged in the exact patterns that made your particular tissues. And now that same atom is being handed hand to hand down a chain of the smallest living things there are, and not one of them knows or cares that it was ever part of a person who had a name, who had a face, who lay awake some night worrying about something that seemed at the time to matter enormously. The atom keeps none of that. It only keeps its 7 protons, its handful of neutrons, its readiness to bond. Everything that made it yours was in the arrangement, and the arrangement is what dissolves. Now nitrate, which is where the relay has carried your atom by this point, is a wonderful and useful thing, and here the story could branch 2 ways. Down one branch, a root finds it. Plants adore nitrate. They drink it up out of the soil water, and they haul the nitrogen back into the land of the living, stitching it into new proteins, into the green machinery of a growing stalk, and so your nitrogen climbs straight back up into a body again, a plant body this time, and the dance resumes almost without a pause. Eat that plant, and an animal takes the nitrogen next. This is the road by which the atoms that were once in a person end up, without the slightest fanfare, in a blade of grass, and then in the muscle of a grazing thing, and then perhaps in the creature that grazes on the grazer. The chain of chemistry becomes a chain of eating, and your nitrogen travels up it as freely as it traveled down the bucket brigade. But down the other branch there waits a different crew of bacteria, and these are the ones who close the great circle. Under conditions where oxygen runs short, in the waterlogged pockets and the airless crumbs of the soil, the live organisms who take nitrate and strip it back down step by step, until what is left is nitrogen gas, plain 2-atom nitrogen, the very same molecule that makes up more than 3/4 of every breath you have ever drawn. They call this denitrification, and it is the exit door of the whole system. Because when your nitrogen becomes nitrogen gas, it floats up out of the soil and rejoins the atmosphere, and there it may drift patient and unbothered for a very long time indeed. The air is a vast reservoir of nitrogen. An atom can wander in it for 1,000,000 years before some lightning bolt or some root-dwelling microbe reaches up and pulls it back down into life again. So one of your nitrogen atoms might be back in a leaf by next spring, and another might ride the high winds over oceans and mountains for longer than our whole species has existed. And both fates are true at once for different atoms, all of them once part of you. And there is a number here worth holding gently in the dark, because it tells you how much of this is going on. A decomposing human body gives up something like 32 grams of nitrogen for every kilogram of its dry mass into the ground around it. That is not a trickle. That is a genuine pulse of fertility. A sudden richness poured into one small patch of earth, and the soil feels it, and the soil remembers it. The chemistry of the ground directly beneath is measurably altered, not for days but for years. If you knew exactly what to test for, you could find the shadow of a body in the soil long after every soft thing was gone, written not in bone, but in the lingering wealth of nitrogen and its companion phosphorus, spread through the earth like a stain of slow generosity. The plants above such a spot often grow greener and taller, fed by a departure, and they never know why, and that too is a kind of dance. the living feeding without thanks on what the dead let fall. I find I cannot walk this nitrogen road without a small feeling of vertigo. The good kind. The kind that comes from seeing how the world is actually put together underneath the stories we usually tell about it. We speak of a person being gone, and in the plain sense of the pattern that is quite true, the pattern is undone. But the atoms are only getting started. They pour out of the ruined proteins, they pass down the bucket brigade of bacteria, they climb into roots or ride away on the wind, and every single one of them is available again, right now, tonight, for the building of something new. Nothing in that chain is wasted. Nothing in it is lost. The chemistry is scrupulously honest. It keeps every atom and simply moves it somewhere it can be useful. So let the nitrogen go on its crowded, patient way up into leaves and out into the sky and around again by roads we have only begun to trace. And now, with the carbon riding into a leaf and the nitrogen threading through its bucket brigade, we come to the strangest traveler of them all. The one Feynman himself pointed to when he wanted to show that even a living mind is only borrowed matter. We come to the phosphorus. And to follow the phosphorus properly, we have to go back for a little while to a rat and a clever trick with a radioactive atom and a 2-week clock ticking quietly inside a living brain. Here is the trick, and it is a beautiful one. If you want to follow an atom through a living animal, you have a problem, because one phosphorus atom looks exactly like every other phosphorus atom. You cannot paint it. You cannot tie a little string to it. It carries no name. So the scientists did something sly. They used a radioactive kind of phosphorus, an atom that is chemically the same in every way that matters to the body, but that quietly announces itself by sending out a tiny signal you can measure. Chemically, it behaves just like ordinary phosphorus. The body cannot tell the difference. It slots it into the same molecules, sends it to the same places, treats it as one of its own. But the physicist standing outside with an instrument can hear it ticking. So now you have a marked atom, a spy wearing the perfect disguise, and you can feed it to an animal and then follow where it goes and how long it stays. They did this with a rat, and they looked at the cerebrum, the great wrinkled front of the brain, the part that does the thinking, and what they found is the line Feynman loved to quote. The radioactive phosphorus content of the cerebrum of the rat decreases to 1/2 in a period of 2 weeks. Sit with that for a moment. Half of the phosphorus atoms that were in that thinking brain are simply gone in a fortnight. Not damaged, not used up, gone, carried off, and replaced by fresh phosphorus atoms that arrived from the food and the blood and took their places at the workbench. In 2 weeks, half. In another 2 weeks, half of what remained. Keep going, and very soon almost none of the original phosphorus is left. The brain has quietly swapped out its own atoms while never once stopping its work. Now think about what that really means, because it is much stranger than it first sounds. The brain kept remembering things the whole time. The rat still knew where its food was. The pattern of memory held steady while the actual particles holding that memory drained away and were refilled, like a fountain that keeps its shape though not one drop of water stays in it. That is the whole mystery in a single animal. The thing that persists is not the stuff. The thing that persists is the arrangement, the ongoing dance, and the atoms are only the dancers who come on for their turn and then step off into the wings. Feynman turned this over and drew from it that marvelous, slightly mischievous thought about the potatoes. The atom of phosphorus that is doing your remembering this month was, not so very long ago, sitting in a field, in a plant, in something you ate. Last week's potatoes, he said, now they can remember what was going on in your mind a year ago. And the mind that did the original thinking has itself long since been carried away and replaced. It is enough to make you dizzy in the gentlest possible way. You are, in a real and measurable sense, borrowing the very matter you think with. You do not own your atoms, you rent them. And the lease is remarkably short. So when we ask where the phosphorus goes when you die, we should first be honest and admit that even while you were alive, it never stopped going. Death does not start the phosphorus moving. The phosphorus was always moving. All death does is close the door on the arriving side. No more potatoes come in. No more fresh phosphorus climbs into the empty seats. And so the outflow, which was always there, finally runs the account down to nothing, because nothing is being deposited to balance it. Where does it actually travel? Phosphorus is precious stuff in a body, and the body puts it in its most important places. It is in every strand of your DNA, holding the rungs of the ladder to their rails, the very backbone of the molecule that spells out how to build you. It is in the membranes around every one of your cells, a skin of fatty molecules with phosphorus heads. And above all, it is in the little energy coin the body spends every second of your life, the molecule that ferries usable energy from where it is made to where it is needed. Every time a muscle twitches, every time a nerve fires, that phosphorus-bearing coin is spent and remade millions upon millions of times. Phosphorus is not a spectator in you. It is the currency of your aliveness. When the dying begins in earnest, all of that machinery comes apart. The bacteria and the body's own enzymes tear open the long molecules, and the phosphorus, which was locked into DNA and membranes and energy coins, is set loose into the wet chemistry of decay. It leaves the soft tissue and enters the soil as small phosphorus-bearing fragments, the kind a plant root would recognize and welcome. And here is a number worth holding. A decomposing human body gives up roughly 10 grams of phosphorus for every kilogram of its dry mass into the ground around it. That is not a trace. That is a genuine deposit, a small buried treasure of exactly the element that most plants in most soils are desperate for. Because that is the secret about phosphorus in the wider world. It is the shy one, the bottleneck, the element that plants often cannot get enough of. Nitrogen has the whole sky to draw from, an ocean of it overhead, but phosphorus has no gas, no atmosphere, no easy reservoir on the wind. It sits in rock and soil and living things, and it moves slowly, and every gram of it is fought over by roots and microbes. So when a body lays down 10 grams for every kilogram of its dry self, it is handing the surrounding plants a fortune in the one currency they can least afford to waste. The grass over an old grave grows greener, and this is why. It is not sentiment. It is phosphorus and nitrogen with it, doing exactly what Feynman said all living chemistry does. Nothing lost. Everything moved somewhere it can be useful. And that treasure lingers. Unlike the carbon, which rides off into the sky as gas within weeks, and much of the nitrogen, which eventually finds its way back to the air, the phosphorus tends to stay near where it fell. It binds to soil particles, it gets taken up by roots and released again when those plants die in their turn, and it works its way into the slow local economy of that patch of ground. The nitrogen and phosphorus levels in the soil around a body climb quickly, peaking by about the 20th day after death, and then the phosphorus especially settles in for a long residence, altering the chemistry of that soil in ways you could measure for years afterward. A body writes its presence into the ground in phosphorus ink, and the ground is slow to forget. There is a quiet symmetry here that I find hard to look away from. The same phosphorus that spent your whole life being cycled through your brain every couple of weeks, arriving and departing, never resting, simply continues that habit after you are gone. In life it flowed through you. In death it flows out of you. The rhythm never really changed, only the direction settled. The atom that helped you remember a face is now helping a root remember how to reach for water, and it does the second job with exactly the same indifference and exactly the same faithfulness as it did the first. It was never yours to keep. It was always just passing through, on the longest and gentlest of errands. So we have followed 3 of the great travelers now. The carbon, breathed up into the leaves and the air, 18.5 parts in 100 of your whole weight, gone gaseous and gone wandering. The nitrogen, handed down the bucket brigade of bacteria up into protein and back to the sky. And now the phosphorus, sinking quietly into the ground and staying close, feeding the next green thing that dares to grow above you. 3 elements, 3 completely different fates, 3 different roads out of the ruined house of the body, and not one of them a dead end. Each road leads somewhere. Each atom is expected somewhere else. But there is one part of you that does not surrender so quickly. 3 of your great travelers leave in weeks or months. The soft, wet, busy chemistry of you unravels fast once the bacteria take charge. And yet, if you were to come back to that patch of ground a year later, or 5 years later, or in the right soil a century later, you might still find something waiting. Something white, something hard, something that held out long after everything else had gone dancing off into leaves and sky and root, the last holdout. The part built precisely so that it would not easily dissolve. So before we send the final atoms on their way and gather up what all of this means, let us kneel down at that stubborn white architecture and ask how even the skeleton, in the end, is talked out of its atoms one calcium ion at a time. Kneel with me then, in the imagination, beside that pale curved thing in the ground. It does not look like chemistry. It looks like architecture. And it is architecture, of the cleverest kind, because your body solved a problem that no bridge builder ever quite has to face. The problem is this. You need something stiff enough to stand on and pull against with your muscles, so it must be hard like stone. But you also need it alive, threaded with blood, able to grow while you are a child and to mend itself when it cracks. Stone cannot heal. Living jelly cannot bear weight. So the body does something wonderful. It weaves the two together into one substance. And that weaving is exactly what makes bone both strong in life and stubborn in death. Look closely, closer than eyes can go, down at the scale where an apple blown up to the size of the whole earth would have atoms the size of the original apple. At that scale, bone is not one material, it is two materials braided together like the strands of a rope. One strand is a protein called collagen, soft and springy, the same family of stuff that makes your skin supple and your tendons stretchy. The other strand is a mineral, a crystal, packed into and around the collagen in tiny hard needles. That mineral has a name that sounds grander than it is. Hydroxyapatite. It is, if you strip the fancy word away, a form of calcium phosphate. Calcium and phosphorus and oxygen locked into a repeating crystal lattice. The atoms sitting in their assigned seats, attracting each other at a little distance, refusing to be squeezed closer. A rock, in other words, grown inside you by your own cells, deposited grain by grain along the soft protein scaffold. Now you can see why the skeleton is the last to leave. The soft, wet parts of you, the water and the protein and the fat, those are food. Bacteria fall on them like a crowd at a feast. But the mineral part of bone is not food in the same easy way. It is a crystal. It does not want to come apart. And the protein part, the collagen, is wrapped and shielded inside that mineral, hidden from the ordinary machinery that digests loose proteins. So while the rest of you is liquefying and rising as gas within days and weeks, the bone simply sits. It waits. It holds the shape of you when nothing else does. But waiting is not the same as winning. The atoms in bone will leave too. They only leave more slowly, and by two different doors, and it is worth walking through both doors one at a time. The first door is for the collagen, the protein strand. Certain bacteria carry a special tool, an enzyme built precisely to cut collagen where ordinary enzymes fail. We call these tools collagenases, which is just a plain way of saying collagen cutters. Think of collagen as a thick rope woven of three cords twisted tightly together, so tight that most scissors slip right off it. The collagenase is a pair of scissors shaped for exactly that rope, and only that rope. Snip by snip, over months and years, the collagen cutters work their way into the bone and take the protein apart into smaller pieces. And those pieces become food after all, and the carbon and the nitrogen and the hydrogen inside them join the same rivers we followed before. Up as gas, out into the soil, into a root, into a leaf, into the body of some small creature that will never know it borrowed from you. And as the collagen is eaten away, something quiet and important happens to the mineral it left behind. The crystal was held in place partly by that protein weave. Pull the weave out, and the little needles of hydroxyapatite are left exposed and loose, no longer bound into a living whole, just a chalky residue lying against the wet earth. Which brings us to the second door. The second door is not biology at all. No bacterium is needed. This door is pure chemistry, the slow, patient chemistry of water and acid working on stone. It is the same process, exactly the same, that hollows out limestone caves and rounds off old gravestones and eats the sharp edges from a marble step over a few hundred years. Water in the soil is almost never pure water. It carries dissolved acids, some from the air, some from rotting plants, some in fact from the very decomposition happening all around. Because remember that carbon dioxide dissolving into water makes a mild acid. And calcium phosphate, that proud hard crystal, has one weakness. It gives itself up to acid. An acid coming into contact with hydroxyapatite pries the calcium atoms loose from their crystal seats, one calcium ion at a time, and once a calcium atom is loosened into the water, it is free to travel, to be carried downward with the seeping rain, to be drawn up by a plant that needs calcium for its own purposes, to move on into the great circulation like everything else. So the skeleton is not permanent, it is only slow. And how slow depends almost entirely on the soil it happens to lie in, which is a lovely and slightly eerie thing to sit with. Your bones do not carry their own clock. The ground sets the clock for them. In a rich, damp, acidic soil, the kind of black fertile earth a farmer prizes, the acid is plentiful and the dissolving is brisk, and a whole human skeleton, the frame that carried a person for a lifetime, can be dissolved away in something like 20 years. 20 years and the last hard evidence is gone, leached out atom by atom into the surrounding earth. But lay that same skeleton in a different bed, in neutral ground or in dry sand where little water moves and little acid gathers, and the clock nearly stops. There the bones can hold their shape for hundreds of years, wading through a span longer than any human memory, longer than most nations, still recognizably the architecture of a person, simply because the water around them never carried the acid to talk them out of their calcium. We even have rough numbers for the softer part, the part that goes first. A body laid in the earth without a coffin, in ordinary conditions, tends to lose all its soft tissue and come down to bare bone within about 5 years. Give it a coffin, a box that slows the traffic of moisture and bacteria and air, and the soft tissue lingers longer, gone in something like 5 to 10 years instead. And at the other extreme, when nothing shelters the body at all, when it lies exposed in the full heat of summer with the insects and the bacteria working at full tilt, the whole soft unraveling can race to completion in as few as 9 days. 9 days from a living pattern to a clean white frame. The range is enormous, from 9 days to several centuries, and every bit of that range is written not in the body, but in the weather and the chemistry of the place. Heat speeds it. Cold and dryness slow it. Acid dissolves. Sand preserves. The atoms are the same atoms everywhere. Only the invitation to leave comes sooner or later. Sit with that picture for a moment, because it undoes a very natural feeling. We tend to think of the skeleton as the true and final self, the thing that lasts, the hard, honest core under all the soft disguise. And it is more lasting than the rest. But it is not the exception to the story we have been telling. It is the same story played in slow motion. The soft parts leave as gas on a breeze. The hard parts leave as calcium in the rain. One is fast and one is slow, but both are simply atoms being coaxed, by warmth or by acid, out of one arrangement and into the next. There is no part of you that is exempt. There is no piece that stays behind forever holding your name. Even the stone in you is on loan. And here is the turn that makes me smile, sitting in the dark thinking about it. Every calcium atom that leaches out of an old bone, every carbon atom that rose as gas, every nitrogen that relayed through the soil, none of them is destroyed. Not one. They are not used up, they are only handed on. So the very moment we finish following your atoms down into the ground and up into the air and out into the water, we are ready to turn the question completely around and ask the far stranger thing. Not where do your atoms go, but where did they come from? And where will they turn up next? And just how far across the whole wide breathing skin of this planet does a single released atom actually travel? Because once an atom is loose, once it has left the ruined house and joined the general circulation, the air itself begins to stir it and mix it and carry it everywhere, and there is a piece of arithmetic about that mixing. An old and famous little calculation about a dying man 2,000 years ago. That will tell us something almost impossible to believe about the very next breath you take. Let me hand you an atom and turn you loose with it, because the traveling is the whole marvel, and I want you to feel just how thoroughly the world passes an atom around. Picture one single atom of carbon that once sat in the tip of your finger. It rises one day out of the wet ground as carbon dioxide, two oxygens holding hands with it, a tiny straight molecule tumbling up through the crumbs of soil. And the wind takes it. Not gently, not to any purpose, just the ordinary shoving of the air. In a matter of days, that molecule can be 100 miles from where it started. In a matter of a year or two, the great slow churning of the whole atmosphere has smeared it out until it is essentially everywhere, thin and even, like one drop of ink stirred through an entire swimming pool until you cannot find the drop anymore. That is the thing to hold on to. The air is not a still room. It is a river with no banks, wrapping the planet, folding over itself, and anything you release into it does not stay released in one place. It spreads until it belongs to the whole sky. And here is where an old, mischievous little sum comes in, one that I have always loved for the way it ambushes your common sense. It is the sum about a dying breath. 2,000 years ago, a man died. Let us say it was on a cold stone floor. And let us say his very last act, as every living thing's last act is, was to push the air out of his lungs one final time. Call him Caesar, since he is the one people always name. That final breath he exhaled carried a certain number of molecules. And I want to actually count them with you. Gently, no rush, because the counting is where the wonder lives. A single breath, yours or his, is roughly 1¼ times 10 to the 22nd molecules. Let me say that number slowly so it lands. 1 followed by 22 zeros and a little more. 12 sextillion and a half in one ordinary breath. In the breath you are breathing right now as you lie there in the dark. It is a number so far past what a person can picture that the mind just quietly sets it down and looks away. But we will not look away. We will use it. Now his final breath, once he was done with it, went where all breath goes, out into that bankless river of air. And over the centuries, over 2,000 slow-turning years, those molecules did exactly what our carbon atom did. They spread. They mixed. The winds carried them over oceans and mountains, up into the high cold layers and back down again, around and around the planet, until they were no longer a breath at all. They were simply part of the general air, sprinkled evenly through the whole atmosphere of the Earth. So now we ask the impertinent question. The whole atmosphere of the Earth has a volume. It is about 5 times 10 to the 18th cubic meters, give or take, that thin shell of breathable air hugging the ball of the world. His single breath had its 20-some sextillion molecules, about 25 sextillion, scattered into all of that. So how thin is he now in the air? You take his molecules and you divide them out across that entire enormous volume, and you find how many of his molecules are sitting, on average, in any one breath-sized gulp of air. And the answer, when you turn the crank on the arithmetic, comes out to roughly 1. About 1 molecule from that man's dying breath in every single breath a person anywhere on Earth now takes. 1 of his every time you breathe. Right now. And now again. I remember the first time that result crawled up my spine, because your instinct screams that it must be 0. He is gone, he is dust, he died before there were books printed, before half the cities you know had names. Surely nothing so intimate as his last breath could reach across all that time and all that distance and touch your lungs on a quiet ordinary night. But the numbers do not care about your instinct. The numbers are patient and they are honest. The reason it works is that both quantities are colossal. The number of molecules in one breath is stupendous, and the number of breath-sized parcels of air wrapping the world is also stupendous, and it happens that the first stupendous number is just about big enough to survive being divided by the second. The vastness of the sky is real, but the vastness of a breath is real too, and they very nearly cancel. If you would rather ask it as a matter of chance, you can. What are the odds that at least 1 molecule of that final breath is riding in the very next lungful you draw? Not the average, but the yes or no of it. And the odds come out to about 99.2%. 99.2. so near to certain that you would be a fool to bet against it. Nearly every breath you take, sleeping or waking, laughing or crying, contains a piece of a man who has been gone for 2,000 years. Breathe in. There he is. Breathe out. You just gave him to the room. Breathe in again. Some of him came back. And now let me twist the knife of the idea kindly, the way I like to. There is nothing special about Caesar. I only used him because he is famous and it makes a good story. But the arithmetic knows nothing of fame. Every person who has ever drawn a last breath poured it into the same river of air. Every one of them is spread through the same sky by now, if they have been gone long enough for the mixing to finish, and the mixing only takes a couple of years. So it is not just Caesar in your next breath. It is a molecule from the last sigh of some shepherd whose name was never written down. A molecule from a queen. A molecule from a child who lived 900 years ago in a village that no longer exists. A molecule from someone who loved someone and lost them and stood at the edge of the same sea I once wrote about, wondering. All of them thinned into the air, all of them arriving in your lungs a few at a time, breath after breath, all night long, and you never feel a thing. You are breathing the dead. Gently, constantly, without ceremony. And one day, a long way off, someone not yet born will breathe you. That is not a poem I am dressing the physics in. That is the physics. The poem is just what is left over once you understand the sum. Now I can feel a sharp listener getting ready to object, and it is a good objection, so let us take it seriously rather than wave it away. You might say, wait, the air does not really mix perfectly. Some of his molecules got locked into the ocean, dissolved into cold seawater. Some got taken up by a tree and built into wood and are sitting in a plank in somebody's floor right now, not in the air at all. Some drifted so high they were broken apart by sunlight. That is all true. The real world is messier than the clean little calculation. And so, if you wanted to be very careful and honest, you would shave that answer down some. Because not every molecule he breathed out is still free and airborne and available to be inhaled. But here is the lovely thing. It does not save your common sense. Even after you are as fussy and pessimistic as you like, even after you throw away most of his molecules to the sea and the trees and the high torn air, the number is still big enough. It might drop from about 1 per breath to some fraction of 1, but it stays in the neighborhood of ordinary experience, not in the neighborhood of never. The conclusion survives the fussiness. You are still, on most breaths, taking in some scrap of the ancient dead. The universe simply is built at a scale where this kind of intimacy across time is not a miracle. It is a Tuesday. And that same trick, that same collision of two enormous numbers, is going to do something even more personal in a moment. Because breath is only the fastest and most obvious of the ways an atom gets passed around. There is a slower circulation, through water and soil and root and flesh, and if we run the very same style of arithmetic through that slower loop, we will not be talking about one man's final breath anymore. We will be talking about how much of a whole particular person, released and scattered across 4 centuries, is sitting inside your body this very instant, woven into you, doing your living for you, while you lie there thinking it is entirely and only yourself. So let us take that slower loop seriously. When Shakespeare died 4 centuries ago, he did not simply exhale one last cloud and vanish. He had spent a whole life exhaling every minute of every year and doing all the other quiet things a body does to shed itself back into the world. And at the end, his body did what yours will do. It came apart into gases and salts and dark rich soil water, and every atom that had been briefly arranged into a poet went wandering off to be arranged into other things. If you add all of that up, the breathing across a lifetime, the waste, the final scattering of the whole body, you get a number for the total count of atoms that one man handed back to the planet. And the number is about 7 times 10 to the 30th. 7 followed by 30 zeros. That is far more than the count of atoms in his body at any single instant, because over a lifetime the same body cycles through its own weight in atoms again and again, breathing them in and letting them go, the way a river is far more water than the amount standing in its channel at any one moment. Now we play the same game we played with Caesar, only slower and wider. We do not confine ourselves to the air this time. We let those 7 times 10 to the 30th atoms mix into everything an atom can reach and still get back into a living thing. The air, yes, but also the oceans, the rivers, the lakes, the top of the soil, all the water that evaporates and rains and soaks and drains. 400 years is a long time for that stirring to happen. Ocean currents turn the sea over. Water climbs into the sky and falls again 1,000 times. Carbon goes into plants and out of animals and back into the air. 4 centuries is plenty of time for one man's atoms to be spread thinly and fairly through the whole accessible skin of the earth. And how big is that accessible skin measured in atoms? It comes to roughly 1.4 times 10 to the 47th. That is the great reservoir dominated by the mass of the ocean into which Shakespeare dissolved. So now the whole thing is just 2 numbers rubbing against each other again, the way it always is. The tiny gift, 7 times 10 to the 30th, divided into the vast pool, 1.4 times 10 to the 47th. That fraction tells you what portion of any random handful of the world's reachable atoms once belonged to him. It is a small fraction. It is about 1 atom in every 20 billion or so. 1 in 20 billion sounds like nothing. It sounds like a rounding error, like a whisper you would never hear. But here is where the largeness of you comes to the rescue, the same way the largeness of a breath rescued the Caesar sum. You are not a handful of atoms. You are about 4 times 10 to the 27th of them, wearing the shape of a person. So take that whole enormous count of you and ask how many fall into the 1 in 20 billion that used to be Shakespeare. You multiply 4 times 10 to the 27th times a fraction of about 1 in 20 billion. And the answer that falls out is roughly 2 times 10 to the 11th. 200 billion. Sit with that for a moment gently, the way you would sit with a coal that is warm but will not burn you. 200 billion atoms in the body lying here right now once did their work inside William Shakespeare. 200 billion of the little particles currently arranged as your fingertip, your eyelid, the wet lining of your lung, were once arranged as him. They helped him hold a pen. They wrote in the blood behind his eyes on some afternoon when a line of verse arrived and he did not yet know it would outlast every empire alive in his day. And then they left him, as they leave everyone, and they wandered for 400 years through rain and wheat and cattle and rivers and the breath of strangers, and some fraction of them, 200 billion strong, drifted into the long chain of meals and breaths that built you. You did not choose them. You could not have refused them. They simply arrived, as atoms always do, and took up the dance you are running tonight. And do not imagine there is anything special about Shakespeare in this except that we happen to know his name. Run the same arithmetic for any human being who died more than a handful of years ago and had time to mix back into the world, and you get numbers of the same towering kind. 200 billion is not a tribute to genius. It is a statement about how atoms are shared, and it holds for the famous and the forgotten alike, for the pharaoh and for the field hand whose name no record ever kept. Every one of them dissolved into the same reservoir. Every one of them is handing atoms to you at this exact ratio, more or less, adjusted only for how long ago they came apart and how thoroughly the stirring has had its way with them. You can push the same idea in the other direction, toward the living, and it becomes almost tender. Take everyone alive on the earth a single year ago. Every one of them was breathing, sweating, shedding, exchanging atoms with the shared air and water the whole time, just as you were. And when you run the sums on that constant traffic, you find that you carry, right now, on the order of hundreds of billions of atoms that were inside each and every other living person 1 year back. Not a chosen few. Not your family alone. Every single one of them. The stranger on the far side of the planet, whose language you will never speak, the newborn you will never meet, the old man asleep in a city you cannot find on a map. Hundreds of billions of atoms out of each of them are in you tonight, and hundreds of billions out of you are, at this instant, in every one of them. We are not separate vessels passing sealed and alone through the world. We are constantly leaking into one another. The boundary of your skin is a convenience of language, not a fact of physics. I want to be honest about these figures, because I do not like a number dressed up finer than it deserves. The Shakespeare count leans harder on estimate than the Caesar breath does. It rests on a single careful reckoning rather than two that were worked out apart from each other, so I hold it a little more loosely in my hand. Maybe it is 200 billion. Maybe, if you weigh the mixing differently, or you argue about how much of the ocean an atom can really reach and return from, it is 50 billion. Or it is half a trillion. The exact figure is not the treasure. The treasure is the size of the thing, the order of it. Whether the answer is 10 billion or 1,000 billion, it is not zero, and it is not small, and it is not a poetic exaggeration. It is a plain consequence of two facts you already believe. There are almost unimaginably many atoms in a person, and 400 years is long enough to mix them everywhere. Put those two truths side by side, and the astonishing result is forced upon you. You do not get to decline it. Notice what has quietly happened while we did this arithmetic. We set out asking where your atoms go when you come apart, and we have answered it by running the film backward, by asking where the atoms in you tonight have already been. And the answer is the same answer, seen from the other end. They came from the dead, they came from the living, they came from the ocean and the wheat field and the air that a Roman gasped and a poet exhaled. What is going to happen to your atoms, the scattering and mixing and rejoining, is nothing more than what has already happened to them 1,000 times over, on their way to briefly becoming you. You are not the beginning of their story, and you will not be the end of it. You are a stretch in the middle where for a few decades a particular set of them happens to be dancing your particular dance. There is no wall around you. There never was one. The census we just took, the 200 billion from one poet, the hundreds of billions from every soul now breathing, is the proof, written in nothing but multiplication, that the self you defend so carefully as yours and yours alone was on loan the whole time, and is quietly being repaid with every breath even as you lie here in the dark. And once you truly see that the boundary was never sealed, a strange and comfortable question rises up in its place. If so much of you was already somebody else, and so much of you will soon be something else again, then what exactly is the you that persists through all this coming and going? What is the thing that stays when the atoms so plainly do not? Let me answer that the honest way, which is to say, I will answer it by refusing to give you the answer you were expecting. Because the thing you are reaching for, the little kernel of you that sits behind your eyes and rides around inside all this borrowed matter, is not made of any special stuff. There is no soul atom. There is no particle stamped with your name that the others gather around. I have looked, and the people who spend their lives looking have looked, and it simply is not there. Every atom in you is an ordinary atom, identical to the trillions upon trillions of the same kind scattered through the ocean and the air and the rock and the bodies of everyone you have ever loved. A hydrogen in your thumb is exactly, perfectly, indistinguishably the same as a hydrogen in a raindrop over the Pacific. If I swapped them while you slept, you would never know, and more to the point, there would be nothing to know, because the swap would change nothing whatsoever. So the thing that stays is not the atoms. We have proven that beyond any doubt. The atoms pour through you like water through a fountain, and by now you feel that in your bones, or rather in whatever this week's bones happen to be. What stays is the arrangement. What stays is the pattern. What stays is the dance. I want you to sit with that word, dance, because it is doing more work than it looks like. Think of a wave rolling across the open sea toward a beach. The wave travels for 1,000 miles. It crosses an entire ocean. It arrives, it rises up, it curls over, it breaks on the sand with a sound you have heard your whole life. Now ask a simple question. What actually made that journey? Did a lump of water travel 1,000 miles across the sea? It did not. Each little parcel of water only bobbed up and down, more or less in place, and handed its motion to the next parcel, which handed it to the next. The water stayed home. Only the shape moved. The wave is real, you can surf it, it can knock you flat, it can carve a cliff. But it is not a thing. It is a pattern passing through a medium, and the medium stays behind while the pattern goes on. You are a wave. You are a very slow, very intricate wave rolling through a sea of atoms. The atoms bob up and down, they come in with the potatoes and the water and the air, they take their turn in the pattern, and they leave again as breath and warmth and waste. And the pattern rolls on. That is why you can lose 90% of your atoms in a year and still wake up as yourself. The wave does not care which water molecules it is using this second, it only cares about the shape, and the shape is faithfully copied forward, moment to moment, the way each parcel of sea faithfully lifts the next. Here is where it gets even lovelier and even stranger, and I want to take my time with it because it is the whole secret. The pattern is not painted onto the atoms like a picture on a wall. The pattern is a set of instructions for how to arrange the next batch of atoms. Down in every cell there is that long, patient molecule, the one shaped like a twisted ladder, and along its rungs is written, in an alphabet of only 4 letters, the recipe for building you out of whatever raw material happens to wander in. It says, take a carbon from here, a nitrogen from there, string them in this order, fold them in this shape. And when the atoms it used yesterday drift away, it simply reads the recipe again and builds the same shape out of today's arrivals. The atoms are the ink. The molecule is the sentence. And a sentence does not care whether you write it in blue ink or black, on paper or in sand. The meaning survives the medium every single time you copy it. That is what I meant years ago, standing and trying to find words for it, when I said the atoms come into the brain, dance a dance, and go out again. There are always new atoms, but always doing the same dance, remembering what the dance was yesterday. The remembering is the whole trick. The remembering is you, not the dancers. The dance remembers itself because it is written down in the folds and the rungs and the wiring, and it keeps rebuilding itself faster than it falls apart. Now hold this next thought gently, the way you would hold something that might be either very sad or very consoling, and you get to choose which. When you die, the rebuilding stops. The recipe is still written for a while, but no one is reading it aloud anymore. The pattern is not being copied forward. The wave, having rolled all the way across the sea of your years, finally reaches the sand, and it breaks, and its shape spills out into a million smaller ripples that go running off in every direction. The atoms are completely fine. Not one of them is harmed. They were only ever bobbing in place, taking their turn. It is the pattern that ends, and the pattern was never a substance to begin with. So there is nothing to bury and nothing to burn. There is only a shape that stopped being drawn. And yet, and here is the thing that keeps me turning it over even now, the atoms carry something out with them when they scatter. Not the whole dance, but the way I have always thought of it, deep in the sea long ago, the molecules first learned to repeat the patterns of one another until complex new ones were formed. They made others like themselves, and a new dance started, and it grew in size and in intricacy across a length of time that no mind can really hold. From masses of atoms with no design at all, up through the twisted ladder, up through protein, up through the first thing that could be said to feel the sun, all the way up to a creature that could stand on the dry land it crawled out of and wonder at the wondering itself. Every atom leaving your body tonight is an atom that has already been through that whole ascent once. It has been star and stone and sea, and very possibly leaf and fish and some other warm creature's beating heart, long before it ever wandered into you. And when it leaves, it is not retiring. It is available. It is stepping off your wave and waiting, with infinite patience and no memory of its own, for the next pattern that comes along and needs a carbon just there, a nitrogen just so. So the carbon that lifts out of the soil above a grave as that quiet gas, the one we followed rising into the air, does not drift off into nothing. It joins the great slow river of the atmosphere, and somewhere a leaf, using nothing but sunlight and the same trick life has always used, reaches out and pulls that carbon down out of the sky and welds it into sugar. And a creature eats the leaf and builds the carbon into muscle, and now your atom is dancing again, a completely different dance, in a body that has never heard your name. The nitrogen you released as that sharp-smelling breath of ammonia gets handed down the bacterial relay we traced, passed from one microscopic worker to the next, nitrate to nitrate, until a root drinks it, and it too climbs back up into the living world and takes its place in some new green pattern reaching for the light. The phosphorus, the very same element that empties out of a rat's brain in a fortnight and out of yours just as fast, leaches into the ground and waits, and one day it too is drawn up into the machinery of something alive, into the rungs of some new ladder, into the little energy coins that every living cell spends to do anything at all. Nothing is thrown away. That is not a poem I am telling you. That is bookkeeping. That is the plainest accounting in all of nature. The atoms are conserved. You may lose your pattern, but the world loses nothing, and the raw material of you goes straight back onto the shelf, fully stocked, ready for the next builder. Every field of grass, every slow fish, every child not yet born is going to be assembled out of atoms that have done this before. Atoms that were somebody. Atoms that will be somebody again. The sea of matter is not a graveyard. It is a workshop that never closes, and the same handful of ingredients gets baked into fresh bread, over and over, world without pause. And if that is true, then the boundary we spent so long dissolving tonight was never a wall between you and death at all. It was a turnstile. It only ever turned one way while you were alive, letting the world in and you out, in and out, a little faster than you noticed. Death does not build a wall. Death takes the turnstile away entirely and lets the whole crowd through at once. The atoms that were shyly filing in and out of you all your life simply stop filing and start streaming. Back into the common pool, back into the endless supply, and the only thing that has genuinely ceased to exist is the arrangement that briefly made them add up to a person who could lie in the dark and think about it. So when I ask again what stays, I find I have talked myself into an answer that is quieter than the question deserved and somehow bigger than I expected. What stays is not you, and what stays is not the atoms. What stays is the capacity of matter to be arranged into a wandering thing, and then, when that arrangement tires, to be arranged into another one. You are one sentence, written in an ink, that has written 1,000,000,000 sentences before yours and will write 1,000,000,000 after. And the ink, unlike you, unlike me, does not run dry. Let me take that ink and count it, because counting is the honest thing to do, and because a number, held gently, can be a kind of lullaby. There was a man in England, a scribbler of plays, who lived and breathed and eventually stopped doing both. Over the whole span of his life, breathing in and breathing out, sweating, shedding, and at the last, dissolving back into the soil the way we have been describing all along, that one man loosed something like 7 times 10 to the 30th atoms into the world. Say that slowly. 7, followed by 30 zeros. It is a number with no picture attached to it, no way to hold it in the hand, and yet it came out of a single ordinary body no larger than yours. Now those atoms did not vanish. They had nowhere to vanish to. They spread into what I will call the accessible world, the thin skin of air and water and topsoil that living things can actually reach and use. And that world, big as it feels when you stand on a beach and look out, is itself only about 1.4 times 10 to the 47th atoms, and most of those are locked up in the ocean, sloshing around as water. So here is the little division problem, and it is the same shape as the breath problem I walked you through before. You take how many atoms one man released, you divide by how many atoms there are to share among, and you multiply by how many atoms are sitting in one living body today, which is roughly 4 times 10 to the 27th. Turn the crank on that arithmetic, gently, no need to rush it, and out the other end comes a number that ought to stop you where you lie. 200 billion. Give or take, 2 times 10 to the 11th atoms in your body, right now, in the dark, that were once inside that scribbler in England. Not near him, not around him, inside him. Part of the hand that held the pen, or the lungs that pushed the air across the vocal cords, or the tongue, or the wet gray folds of the brain that arranged the words. 200 billion of his atoms are wound into you tonight, and you never asked for them, and you cannot give them back, and they are doing the ordinary work of being you without the slightest memory of the ordinary work of being him. I want you to sit with how strange it is that the number is that large and yet feels like nothing. 200 billion is more than the number of stars you could ever hope to see, and it is a rounding error against the 7 octillion atoms that make you up. It is a whisper of him in an ocean of you. But then, the trick of it, The thing I find myself turning over like a smooth stone is that it is not only him. Pick anyone. Pick a queen who died 1,000 years ago, or a child who died last spring, or the person who lived in your house before you and left no name behind. Run the same division. You get another 200 billion, and another, one helping for every human being who has ever lived long enough to breathe and die. They are all in there. You are not haunted by one ghost. You are quietly built, in tiny part, out of every ghost there has ever been. And do not think this sharing only reaches backward into the dead. It reaches sideways into everyone alive at this very moment, which is the part that startled me most when I first bothered to work it out. Each of us carries, on average, hundreds of billions of atoms that were sitting inside every other living person on Earth just 1 year ago. Every one. The person you love who is asleep beside you. A stranger on the far side of an ocean you will never cross. A newborn in a city whose name you cannot pronounce. 1 year ago, hundreds of billions of the atoms now doing your breathing were doing theirs. You have been exchanging pieces of yourself with the entire human species continuously, without consent, without ceremony, without ever once feeling it happen. The air is the marketplace, and the trade never closes. So when somebody dies, and a year goes by, and you go looking for what is left of them inside a stranger, the honest fraction is a small and delicate thing. Roughly 1 hydrogen atom out of every 2.1 times 10 to the 16th. That is 1 part in 21,000 trillion. Vanishingly rare. A needle not in a haystack, but in a continent of haystacks. And yet the number is not zero. It is never zero. That is the whole tender business of it. The specific person, that exact bundle of history and habit, is spread so thin across the world that the concentration rounds to nothing anywhere you sample. But integrate across the whole of you, add up every one of those absurdly rare atoms scattered through your 7 octillion, and there they are again, present, accounted for. A faint continuous signal that a particular someone once walked around wearing this matter. I keep calling it a boundary, the edge of you, the place where you stop and the world begins, and I have to confess now that I have been using a word I do not quite believe in. Where exactly is the edge of a candle flame? You can point to it. You can say, there, the flame ends there, and yet the flame is nothing but air and wax passing through a shape, and the atoms in it this second are not the atoms in it the next. The flame is a process wearing the mask of a thing. And you, lying there, breathing, warm, are a slower flame and nothing more. The boundary you feel so certain of, the skin that seems to say inside here is me and out there is not, is a turnstile that was never a wall, and I showed you already that death does not build the wall. Death only takes the turnstile away and lets the crowd stream through unmetered. Think about what that means for the question everyone secretly asks and no one likes to say plainly. When did the atoms of you become you? They did not. There was no ceremony where the world handed them over and declared them yours. They wandered in from last week's potatoes, from the water in a glass, from the breath of a person 3 streets over. They took up the dance for a while, they held the shape, and they wandered out again to try the shape of something else. More than 90% of them do exactly this every single year while you are alive and well and utterly convinced of your own solidity. You are, right now, in the healthiest middle of your life, already almost entirely made of atoms that were not you a short while ago. You have been dying in this gentle atomic sense and being remade your whole life, and you called it living, and you were right to. That is why I said the instant of death changes so little for the atoms. To them it is the smallest possible edit. The intake stops. The outflow continues as it always did, only now with nothing coming the other way to keep the pattern topped up. The dance does not end with a crash. It winds down like a music box running out of turns, each note a little slower, a little further apart, until the last few atoms take their positions, find no partner arriving to lead them, and drift off to join the enormous unhurried waltz of everything else. No atom mourns. No atom notices. The methane rises, the ammonia seeps, the calcium leaches, the carbon lifts on the morning warmth into the waiting mouths of leaves, and not one particle among the 7 octillion feels the loss, because there was never a self hiding inside any single one of them to feel it. The self was the arrangement, and the arrangement is the one thing in the whole story that was never made of anything you could hold. There is a line of his I have circled back toward this entire evening without quite letting myself say it out loud, and I will let a piece of it out now, because we have finally earned the size of it. He wrote, thinking about exactly this, about standing at the edge of the sea and being made of atoms that wonder at being made of atoms, that he was a universe of atoms, and also an atom in the universe, both at once. Read it too fast and it sounds like a pretty phrase. Read it the way we have been reading everything tonight, slowly, with the arithmetic underneath it, and it stops being pretty and starts being simply true. You are a universe of them. 7 octillion. More than the stars in more galaxies than you can name, all cooperating in one warm shape for a little while. And you are, at the very same time, a single atom's worth of matter against the sky, on loan, briefly gathered, soon to be redistributed, one small quantity in an accounting so vast the ledger has no last page. I told you at the start that I would talk myself into an answer quieter than the question deserved. Here is another turn of that same quiet. The atoms that make you are not rare. They are the most common things there are. Hydrogen, oxygen, carbon, a little nitrogen, the ordinary furniture of the cosmos. What was rare, what was almost impossibly rare, was the particular way they leaned together in you, the specific dance, the pattern that could sit in the dark and worry about ending. That pattern is the treasure, and the pattern is not written in the atoms. It is written in the arrangement of the atoms, the way a melody is not written in the air it moves. Think about that for a while gently, the way you would turn a smooth stone in your hand in the dark. The pattern is not written in the atoms. If I could somehow catalog every one of your 7 octillion atoms, label each one, list where it sits and how fast it moves, I would still not have caught the thing that matters. Because the very same atoms, poured out on a table in a heap, are not you. They are a pile of the commonest stuff in the universe. What made them you was the leaning, the arrangement, the perpetual motion held in one particular choreography by the attracting and the repelling that Feynman put in that first great sentence. Attracting when they are a little apart, repelling when you squeeze them together. Out of just that one rule of push and pull played across octillions of tiny partners comes everything. The stiffness of a bone, the softness of a lip, a thought about the sea. So here is a thing I find lovely, and I want to give it to you slowly, because it is the kind of idea that opens like a flower if you do not rush it. When you die, and the dance stops, and the atoms begin to wander off into the soil and the air and the water, not one of those atoms is diminished. Each carbon is exactly as good as it ever was. Each hydrogen is ready, this instant, to join some other pattern. The atoms do not mourn. They cannot. They were never the thing that lived, and that is not a sad fact. That is the escape hatch, because it means the thing that lived was never a position you could lose in the ordinary way. It was an event. It was a happening. It was, as he said, a dance. And a dance that has ended is not destroyed the way a broken cup is destroyed. It is simply, for now, not being danced. Let me put a small picture beside that, from the ordinary world, because I do not want this to float off into fog. Think of a bonfire on a beach at night. People gather around it, and the fire is bright and particular. It crackles in its own way. It leans in the wind in its own way. You could almost give it a name. And yet the fire is not the wood. The fire is a process running through the wood, a pattern of burning that moves from log to log. When one log is spent, the flame does not die. It has already passed itself along. And when at last the whole pile is embers and the fire goes out, where did the fire go? It did not go anywhere. It was never a thing to go. It was a way the wood was behaving. The heat spread out into the night air, the light already racing away across the water, the carbon lifting up into the dark. Nothing was lost. Something simply stopped happening in that one place. You are a fire that worries about going out, but the atoms you are burning through were on their way somewhere all along, and the warmth you make of them while you have them is real. That is not nothing. That is very nearly everything. Now I promised you numbers all through this talk, and I do not want to leave the arithmetic behind just because we have wandered into the soft country of meaning. The numbers are the meaning here. Let me hand you one more and hold it up to the light. More than 90% of the atoms in your body are swapped out over a single year, even while you are perfectly alive, walking around, sure of yourself, certain you are one continuous thing. 90%. Which means the body you will carry into next summer is very nearly not made of any of the material you are wearing tonight. You have already survived the loss of almost all of yourself again and again, dozens of times over your life, and you never once felt it happen. You did not wake up one morning feeling 90% replaced. You felt like you. Because you were the dance, and the dance went on, borrowing new dances as the old ones tired and slipped away out your breath and your skin. So I ask you the sly question, the one I have been circling all night. If losing 90% of your atoms a year never troubled you, never even reached your notice, then what exactly is the last handover, the one we call death, except more of the same? The intake stops. The doors that let new atoms in swing shut, but the outflow, the great patient outflow that was always running, simply keeps on running until the account is empty. Death is not a wall. Death is the moment the traffic goes one way. The atoms had always been leaving. They had always been arriving too, and that was the only difference, and now that difference is gone. The river does not stop at the sea. It just stops being called a river. I want to sit here in the quiet with the phosphorus for one more moment, because of all the atoms that one carries the strangest little parable. Feynman kept coming back to the radioactive phosphorus in the rat's brain. The atoms that cut themselves in half, in number, every 2 weeks, in the brain. In the very seat of the thinking, the place you would most want to believe, holds still. Even there, especially there, the atoms are pouring through like water through a fountain. The fountain has a shape. You can photograph the shape. You can admire the shape. But if you put your hand in, you touch only water that is already leaving. Your memories, whatever they are, whatever a memory finally turns out to be, are not stored the way a jewel is stored in a box. They are held the way the shape of the fountain is held, by the endless replacement of the very stuff that makes them. Last week's potatoes, remembering the year before last. Matter that has moved on entirely. And yet the pattern remembers. That is the deepest magic trick in all of nature, and there is no trick to it. It is only atoms, doing the one thing atoms do, arranged in a way that happens to keep its own recipe. And when the arrangement finally lets go, that phosphorus, so briefly yours, so recently arrived, goes down into the soil at roughly 10 grams for every kilogram of your dry weight, and it does not sit idle. Phosphorus is greedy for company. It binds, it locks into the ground, it waits in the dark like a seed, and then a root finds it, and up it comes into a green blade, into a grain, into the body of some animal that eats the grain, into perhaps a child who will one day lie awake worrying about exactly this. The phosphorus that spelled out a thought in your head becomes the phosphorus that will spell out a thought in a head not yet born. It does not remember you. It carries nothing of your pattern forward. But it is ready, always ready, to be written on again. Every atom in you is a blank page that has already held 1,000 stories and will hold 1,000 more, and never once keeps a word of any of them. That is why it can be used again. Forgetting is what makes the atoms eternal. Let the nitrogen do its relay then through the bacteria and back to the air. Let the carbon lift as that quiet gas and drift until a leaf drinks it down. Let the calcium linger longest of all in the slow, hard patience of bone, 20 years in a hungry soil, hundreds of years in a kind one, until at last even that dissolves and joins the wandering. None of it is in a hurry. None of it is anxious. The anxiety was yours, and the anxiety was made of atoms too, and it will disperse as gently as everything else, into a stillness so complete that the word peace hardly seems large enough. You spend a life being a verb, and you end as a return to nouns, and the nouns were never the frightening part. They were only over the beach the fire burned upon.